I am a Boeing engineer. I have been for the last 5 years. Before that, I studied electrical engineering and a minor.
Saxon, you have some kind of echo. Is there, somebody says disable the green speak indicator? I don't know what that is.
I'm moving into a different room.
Well, is there volume on your?
I'll check it out. I'm going to put it on a bed. Is this better?
I don't know. We'll find out.
Is that any better, guys?
I think that's better. So,
okay.
So tell everybody a little bit. You got light right on the corner though. If you can move slightly, there's a light over your right over your head. That's probably a little bit better.
A little bit better. We'll go on to the spreadsheet anyway. That's the important part.
Well, no. We have time. Do you have somewhere you have to be?
Kinda. So I'm working remote right now, so I am going to be probably visiting my brother, who I'm living next to. That's why I don't have the best setup. I'm in an Airbnb condo right now.
Okay.
I'm not at home. Let's see. How about this? Is that better?
I think so. Yeah.
Well, wait.
I don't want to make you uncomfortable though.
So anyway, if you can hear, it's all good. I'll probably move around anyway. The hosts did not buy very good chairs. Let's say that. Okay. I ended up breaking the only one left.
So you work for Boeing. Anyway, you know, I looked on your LinkedIn and it said you were a Vanderbilt student. Is that a while ago?
Yeah, I haven't bothered to update that because I've been at Boeing the whole time. I don't even think I made a new resume. Okay. So yeah, I've been in quality engineering at the Everett Twin Aisle plant for the last 5 years. So one of the things that I think that I haven't seen enough perspective on this, both on Tesla and in particular the Boring Company in terms of industrial engineering. We talk a lot about manufacturing engineering. Sandy Monroe brings up Dr. Deming a little bit. Not sure if you've personally heard of them.
Dr. Deming, sure. Yeah.
Yeah, like the godfather of quality engineering.
Yeah, if you for those who don't know Dr. Deming, he's a huge hero in Japan.
Yeah, he's pretty much he is personally very responsible for their like 1950 to 1970-ish Japanese economic miracle.
Yeah.
He basically helped invent the Toyota production system with Taiichi Ohno.
Yeah.
So anyway, another personal interest I have in the Boring Company is like since moving to Seattle 5 years ago, I don't own a car. I've been just biking and walking everywhere for the most part, take public transit or Uber. But I came from Cincinnati where back when I was a kid, we were driving a lot. So I've pretty much had pretty good experience with all major North American modes of transport. And I think based on this spreadsheet I've made that I emailed Warren about, I think this new one is going to absolutely blow them all away, unless I'm missing something. So
let's start with this. Yeah. I think we roughly agree that their cost of per mile of tunnel is going to be somewhere between $5 and $10 million when you include stations and other things like that, right? And maybe they're saving some money by selling boring bricks as a result, but ballpark of you have, I think, close to $6 million a mile.
Yes, for the most part, but yeah.
Well, I think we believe, talking to Boring Revolution, who is the Boring Revolution channel, he's in the chat. We're pretty confident that they're close to $5 million a mile. Then the question is, can they drive costs down further, maybe get down to $4 million a mile? But then you have to add stations in, and it really depends. As I was saying before you got on, if you're in a densely populated area with a lot of stations per mile, then the cost per mile is going to go up. If you're in a sparsely populated area where you're doing tunnels that are between cities, then the cost per mile is going to go down because you're not adding as many stations. And then you're going to have some destinations where they're going to pay to build the station. They're going to pay you to build the station, right? Even if you're owning the system yourself. And I want to take a step back. I think you and I talked about this in emails, but I see two different models. Model number one is what they're doing in Las Vegas right now, where Las Vegas pays them to build, or the Las Vegas Convention Center pays them to build the tunnel and the stations. And Las Vegas Convention Center Authority owns the tunnels and pays Boring Company to operate the system. But another model that I like, and I think a lot of other people like, and somebody said that Miami is pushing for this, is Boring Company builds the system on its own dime, charges fares, and gives the city a cut. right? The city gets 10% of revenue. Can you tilt your laptop down a little bit? Your mouth is off screen.
How about that?
Much better. Much better.
Okay.
So
I think I left a comment in this valuation sheet. We can talk more. But at least what I learned in economics school is I think the Coase theorem applies here, which states that in general, when transaction costs are near zero and where people are acting at least approximately rationally, it usually doesn't matter how you divide up the initial property rights or set up the transaction structure. Usually the allocation of resources ends up being the same in the end. So I suspect that mostly factoring out politics, that's a big question. And do consumers behave the same way? I think the economics of it are going to probably end up being the same in terms of how much money eventually ends up.
So I'm going to disagree with you on that.
Okay.
I think that would make sense in the private sector, but when you're dealing with the public, when you were dealing with government, then I think and by the way, the Coase theorem is by an economist named Ronald Coase. I believe he won a Nobel Prize possibly for the Coase theorem.
Yes, he did.
He's very big on transaction costs. And if you have low transactions cost, if you can get transactions costs down, then the economy works more efficiently, which is one of the great things about robo-taxis is if you can reduce the cost of transportation, you're effectively reducing the cost of transactions.
Exactly.
So
I'm not sure of that assumption. I'm just saying if those conditions do apply, and I'm not sure how much they do, then that would be the likely outcome.
Right. So my pitch on that is,
as we know, there's plenty of inefficiencies too.
Well, no. So my pitch on that is if you're a local government and somebody comes to you and says, hey, we want you to spend $50 million or $500 million building a tunnel system, they're going to go, we don't have $500 million. If you go to that city and say, hey, we're going to build a tunnel system for you at no cost to the city. When we're done, we're going to earn revenue from fares or robo-taxi rides or leasing out space in our stations to vendors, and we'll give the city 10% of our revenue forever. Now, as a politician, I'm sitting there saying, I don't have to pay anything. You're going to fix my traffic problem and you're going to fix my budget problems in the future. This is a note from forget about the economics and, whether the city, and you could see a city saying, well, we want 15%, or you could see a city saying we want 20%. And then you could see some negotiation back and forth. I was saying before,
I agree.
Boring company goes to Cleveland, says, this is what we want to do. Cleveland says no. Boring company goes to Cincinnati. Cincinnati says yes. They build the system in Cincinnati. Every voter in Cleveland votes out every politician in Cleveland for being dumb enough not to say yes to this once they see what's happening in Cincinnati. Why don't we have this?
I believe you're right. That's probably the most likely, because I think especially between the fact that the world's currently second richest person has more than enough money to finance this and owns 90% of the equity right now, as well as the fact that if my model is even approximately correct to within the cash flows they're going to be spitting off from this are going to be so high that they could easily self-finance. So their cost of capital, there'd be an arbitrage opportunity versus what the city could get selling bonds. And I think this would be such a political win for anyone that I think it's going to have wide support pretty much anywhere in the world, regardless of the local situation.
Right.
Multi-party, two-party, even authoritarian systems. But
let's take a step back from something you said there about Elon financing it. So I don't know if Elon likes writing $500 million checks. I see Elon saying, hey, Boring Company, go out and do a funding round. SpaceX just did a funding round, I think it was originally $850 million. I think it ended up being over $1 billion, 69 investors. I think that ended up being 80 some investors. Boring Company is not going to have a problem doing a funding round and going out and saying, hey, we're going to do this project in Miami. It's going to cost us $500 million to build this out. And then here's the revenue and profit model for the future once we build this thing, right? I'm ready to invest.
I know.
It's a no-brainer for me.
That's why I emailed you. We didn't get enough people for the
Saxon is a member of the email list that you can join on the link in the link in the description below. And we have talked about this before. So Saxon, let's talk about the operations of the tunnel. How do you see, let's forget about who owns the tunnel for a second. Let's just assume there's a tunnel, right?
Mm-hmm.
Or maybe you need to put an ownership on it, but how do you see the tunnel making money? What's the model?
Can I share my screen, please? It says
I don't
host
know.
disabled. It says host disabled participant screen sharing. So I think you might have to click something. In the meantime, I'll just switch over to the tab. You guys might lose my face though.
Okay, I think I just enabled it.
All right, well, let me try it out. There we go. So this is how I looked at how this might get valued. So basically taking Will's numbers from the Boring Revolution videos, there's another sheet on the construction tab, which we can look at later, where I go over some things that Will hasn't talked about, but mostly just starting with the numbers he's already put out there for cost per mile. Max capacity per mile, this is way too low, but this is kind of just a linear model. I'm not really accounting for the drastic differences in the utilization rates that we'll see on like highly trafficked urban routes versus the majority of the roads out there, the long tail of less trafficked routes that are mostly just there for convenience rather than capacity constraints. So I'm just modeling across the entire system. If you look at like the average on that power law curve, probably 20,000 a day, I'm guessing, to work out to maybe total of 100 million passenger miles per day if this thing is at scale.
Okay, so when you say passenger miles, I see two different types of ways this is going to work. One is you have the system owns vehicles that drive around and give people rides, like a robo-taxi system, internal. Well, so, okay, the simplest thing is everything, the vehicles never leave the system. It's all internal station to station rides. There's another model where the robo-taxis can leave the system and take someone home or take someone to some destination that's outside the tunnel system. And then there's a third model where I have a self-driving car that's an EV that meets the standards for the tunnel, and I can drive in and pay a toll. So you've kind of got it down to a 30-cent toll per mile. Is that per vehicle? Is that per passenger? Is that, do you see, are you trying to average across three, are there more?
I just kind of average
models?
across all of those. Yeah, I think I would break it down eventually to that, but that was so complicated. The key input here for me really is this construction cost per mile, as well as to some extent the like annual maintenance cost per mile. I'm really not sure what that is. Well, as this note says here, right now, the loop management fee for the convention center is 167K per month. I suspect this is probably mostly the driver's salaries that they're currently paying or will be paying, but I don't know what else is driving the costs. It's probably a lot less than regular road maintenance because you don't have so many environmental stresses or weather to deal with. Nor are you going to have heavy semi trucks or lorries if you're in the UK. You're not going to see those doing a bunch of roadway damage. So I think the roads should probably last a long time. So I'm not really sure how much that should cost. But anyway, I think that the construction costs are the most important input. For toll, honestly, that's a bit of a guess, but the initial fare price is going to be $2 per mile roughly. If you guys have seen what they've posted for the LVCC loop expansions. With Robotaxi, as we know, if they're running like simple Teslas on the 4680 battery packs, that part should be about 15 cents per mile, if not less. I think we'll see some modifications to the vehicle design, some of which you've proposed, Warren. We'll get into that later. Like,
I think
the windows.
I think the Austin Berlin Model Y is going to be less. It's going to be 10 cents a mile.
That could very well be. I just wanted to be conservative. So basically, the way I came to this is we already know that in most developed countries, people are willing to pay an average of roughly 50 cents per mile to have personal high-speed transport with a car. So if you figured maybe that drops to like 45 cents per mile and the combined price the consumer sees is maybe 40 to 50 cents per mile. That was just my initial guess, averaging out all of the people. Some might pay more for express lanes if there is any traffic somehow, or at least at like surface congestion at a particular venue, like a sporting event. I'm very much open to that number being changed, but it's really hard to see because we've never seen a system like this. And at least in every country I've ever heard of, there usually aren't universal toll roads. There are just like roads that are offered up as public goods, and so they get overconsumed because it's the tragedy of the commons. So there could also be strange consumer psychology going on that may be culturally dependent, depending on the locale, where people have like just like a bad reaction to having toll roads everywhere. So this, I don't really know, but these are just kind of the implications of that. This spreadsheet, I think Warren, you probably posted a link somewhere.
I didn't post a link to the spreadsheet, but I can.
Okay, yeah, why don't you do that at some point or at the end? That is going to be something you can't modify my copy, but if you make your own, like you can play with these numbers. So if you want to see, or let's say you want to make like do it in 5-year chunks and then add it up, you could start with $2 per mile and all of the numbers change. Maybe it goes down to 10 cents per mile plus whatever, 5 cents per mile toll for like your tiny single person autopod or whatever. This is just kind of what I settled on for a starting point. You can play with all of these as well. And this one's coming from the construction tab. I think the bottom line is if they can get the construction costs all in, including the stations and subtracting out whatever profits they make from bricks, I think they will make so much money just by scaling the network as quickly as possible that I'm not too concerned with the accuracy of trying to predict the average capacity or tolls at this time. Because I believe what will happen is just the standard thing you see from most businesses. They'll start with the low-hanging fruit where they can earn $2 per mile. And for a very long time, as the system scales, there will be far more demand for this highly convenient and safer option. They may not perceive it as safer at first, but it will be. But just so fast. The price is probably going to be above $1 per mile for quite a while as the system scales in a given city.
Hey, just really quick, for those who are watching live, I put the link to the spreadsheet in the chat. And if you're not watching live or you don't have access to the chat, I put a link to the spreadsheet in the video description. Sorry about that.
That's fine. I just remembered because of the time zone mix-up, I need to text someone else I was going to meet at this time. Sorry about that.
So while Saxon's doing that, I'm just going to look at the comments the chat comment really quick and see what else we're missing. So Jay Lizard says, how many people will be in a mile of tunnel during a busy hour in a large city? So Jay Lizard, if you can picture a vehicle with, let's say the average vehicle has 4 passengers and the average vehicle is going, let's say it's a large busy city, you're probably averaging, 30 miles an hour, 40 miles an hour. If the vehicles are 10 feet long, I'm making up the number, they're probably longer than 10 feet long, but let's say they're 15 feet long and there's 5,000 feet in a mile. Let's say they're 20 feet long, there's 5,000 feet in a mile, that's 250, probably 200 vehicles times 40 miles an hour. Saxon, do you have a sense of the volume capacity of how many vehicles, how many people will be in a mile of tunnel during a busy hour in a large city? I guess my answer would be a lot, thousands.
Probably a lot. I mean, if you want to, we can get into, I think the throughput numbers are going to blow people's minds actually. And I think what Elon has put out on Twitter could be lowballing it by like a factor of 3.
Well, you can imagine the 16 passenger minibuses, right? I think there's going to be I think there's going to be a minibus based on the Cybertruck platform that will seat at least 16 people, and more in poorer countries, they're going to squeeze 25 or 30 people in these things. What's this?
I got to go snag a plug, but I think you guys should look at this in the second while I'm gone. So this was what Elon had posted in response to some criticism in 2019 that, oh, well, this won't carry more than a subway. He claimed that the 16 passenger autopods, and like you're saying, probably based on Cybertruck platform, but probably made more aerodynamic than that though. So maybe not stainless steel that can't be rounded because there are limits to how aerodynamic you can make that. Plus it's not really perfect for a round tunnel. You might have something more circular in cross section, like what Hyperloop's doing. So he's saying 150 mile per hour with the 16 passenger pods every second of headway. that turns out to 57,000 per hour. So I'm going to snag the plug, but you can see a variety of different scenarios here based on different possible amounts of passengers per vehicle at peak throughput, as well as the minimum headway. So headway would be measured by the number of seconds between the front bumper of one vehicle and the front bumper of the vehicle behind it. So first of all, the LVCC initial system, probably 3 seconds of headway. And once COVID's over, that would be 4 passengers per vehicle. That's already hitting their 4,400 contractually required peak capacity. So I'll let you guys check this out. I'm gonna go get the plug before I lose power here.
So Jay Lizard, I think this roughly answers your question that you'd be able to get 4,800 passengers per hour through the system. I don't know if it makes sense to talk about it on a mile of tunnel basis for that. And you can see Elon's 2019 tweet. If you shrink the distance or time gap between vehicles, you can get more capacity in the system. You can see in Saxon's model here, the maximum passengers he has in the vehicle is 16. You could easily see, if you've ever been to a crowded country, you could see squeezing 25 or even 30 people in one of these, in something the size of Cybertruck. If you design it right and you cram people in, you could probably get 25 or 30 people in. So yeah, it's all hypothetical, but you know, it's not crazy talk either, right?
Yeah, exactly.
Yeah.
Especially, this is where I was getting, Elon might be lowballing it with the 58K per hour, because honestly, with autonomy, I don't understand any particular reason why you would have a 1 second headway, because like the autonomy is not going to have any issue with reaction time. So if you were to do the math over here, the example vehicle lengths here, if you're going with like a big vehicle that holds like at least 12 people, the best comparison right now would be like a Ford Transit passenger van. Might be called something different in other countries. That's what it's called in America. That is ranging from 18 to 24 feet in length. For an AEV autopod, autonomous electric vehicle, you would probably get rid of the engine bay. You wouldn't really need a frunk, most likely, because there's already storage in the vehicle itself, in the cabin. You wouldn't really need the inefficiently spaced driver's seat because there would be no driver. So that alone, I think, would cut the length by roughly 4 feet. So if you had a vehicle that large, it would probably be roughly 19 feet long. If you needed, let's say, just for the merging during high speed, just like, you know, let's say the autonomy can handle merging at any speed because the physics isn't that complicated. And you really just need this much space to make sure you have safety margin to actually fit the car in the slot. Let's say that's 3 feet from the rear bumper to the front bumper. That means you need a total slot per vehicle of 22 feet. At 155 miles per hour, that would mean you need a 0.1 second headway. So that gets you up to more passengers per hour than you would ever possibly need for any single route, just out of 1 lane of tunnel. And some reasonably sized vehicles that we know they can build. The only question with this scenario is whether this headway is actually something they can safely achieve with autonomy in the tunnels. For comparison, in that scenario, that's moving more passengers in 1 hour than ATL, the Heartland, whatever, International Airport in Atlanta, which is, I think, North America's largest airport. They move about 100 million passengers per year, not in 2020 because the air travel industry has collapsed recently, but that's about maybe 300,000 passengers per day, assuming some days are busier than others at ATL. So this could conceivably, even if you double this number, move as many passengers as the entire Atlanta airport in 1 hour. And since not even, I think I read somewhere that the currently highest trafficked route is on, like, if you're familiar with Islam at all, there's this pilgrimage they do called the Hajj. So there's a lot of people who are like trying to go around various significant religious sites around Mecca. And and neighboring places where they built a gigantic over budget train to do that. So if that represents the highest trafficked route, and even that only does, I think, like 70,000 per hour, if I remember correctly. So all this to say, even if you have the mostly individual scenario where everyone wants their own pod in richer countries, and they're all paying like 50 cents per mile for it, that still comes out to more like a typical lane of highway is like 2,000 per hour if there's no accidents when it slows down to 0. So any claims that this system is not going to meet the throughput and why don't you just build a train is just so wrong, because a train, like typically, maybe Will can comment better, but you're looking at roughly like, yeah, you're getting 1,000 passengers per vehicle, but from what I'm reading, the minimum safe headway you can get away with for a train is 90 seconds. And that just gets decimated by anything resembling 3 seconds or less with large vehicles, because also the cost is so much lower. The convenience to the passengers and the actual value you're providing for the journey is so much higher. If autonomy works out in the tunnels, which I think it will, we'll get into that later, I don't see any reason why you can claim that this system is not going to be able to have enough capacity. Like let's say even in Manhattan, which is our biggest, densest city here in North America, you could probably build one tunnel under like every other major north-south avenue on Manhattan Island. And that would cover the entire like express lane traffic of the whole city. The main limiting factor would be how many stations are you willing to build on the surface, and what is the cost of that real estate, and what is the impact to traffic like on the surface, like what's the second order effects of that.
Hey, one of the criticisms I saw in the chat, and I've seen it from Thunderfoot or Thunder Idiot, was that the real bottleneck is at the stations. That's really it's not that just flowing people through the tunnels, is that you've got to stop at stations, and that's where the real bottleneck is. What's your response to that?
So, well, first of all, I'm not a traffic engineer, but I probably know more than the average person because I have curiosity about a lot of engineering topics. So I've got a cursory knowledge of this. So tunnel capacity, I thought Thunderfoot, I don't really give a lot of credibility to his arguments. I would recommend you watch Will's videos on that. They're apparently disingenuous, because I seem to recall him saying tunnel capacity would not work either. For station capacity, I did an attempt to estimate that here. So just like this is basically set up based on what the fire protection report is saying about the Las Vegas loop. So that's a good example of what like a parking lot like station could look like. The big advantage here is that unlike a train or a bus, you don't have to have a giant vehicle stopped that's waiting like up to 30 seconds or more at high capacity for a bunch of people to get on, swipe a card, everyone else to get out. And then you got like some people who are either just really slow or they have mobility issues or whatever. And then occasionally it's even longer if you need like the wheelchair ramp to lower, etc. With this, if you have even just the 4 passenger per vehicle model, the above ground stations 1 and 3 at the LVCC have 14 vehicle stalls right now. And if you assume, let's say, just go out and watch your average parking lot, on average, I think it's going to be 15 seconds to load up a vehicle. That's probably high. I'm honestly probably 8 seconds is more realistic. But we'll be safe about that. The minimum average headway that you could achieve if you just divide the load time by the stalls is roughly 1 second, which means that you could be launching a vehicle into the tunnel just from one ramp and one station at 13,440 per hour, which is about as much capacity as many smaller trains offer at their peak. So I don't think that's realistic because you can just have more and more ramps, as many as you need. Everything okay?
It's a comment. What happens in a car when someone has a heart attack? The same thing that happens in a car anywhere else when there's a heart attack.
Yeah, well, actually, I would disagree with that because this is going to be a system in which in the fire command center, as well as potentially within the cars themselves, there very well might be emergency response systems that can get you help faster than you would on a roadway.
Well, not to mention that the robots actually could just take you to the hospital.
Yeah, exactly. That's what I mean. It might be able to take you straight there. And if the whole city has less traffic, then there's going to be less things slowing down the emergency vehicles. So come on.
Yeah.
Anyway, so if you want more of these, first of all, if you just upgrade to the 12 passenger vehicles, suddenly you're hitting as much capacity as an entire train system is getting. And if you want more, you just build more ramps in parallel. Like this is another one where the limiting factor is not going to be passengers per hour. It's going to be the last mile problem of like, what is the optimal density of stations within a given area to maximize convenience versus trading off like the system costs of the, maintaining some degree of roads on the surfaces versus how many do we convert over to other uses of real estate, like parks or whatever. Elevators do have much lower throughput. That is certainly a valid criticism. There was a video from last year in which I saw someone drive into the Hawthorne Tunnel, which, as many of you probably know, has an elevator. Not sure if that's the end state of it, but that's the elevator they have now. That one took them 10 seconds to slowly drive into the elevator and for it to start moving. And then it was 50 seconds to go down what looked like maybe 20 meters down to where the tunnel begins. And it was probably about that fast. So if it's just moving people in one direction for some reason, it's not also taking people out, just to be conservative, that would be about a, let's say 90-second cycle time. Like it can probably move faster on the way up when it's unloaded, I'm guessing. So that would only be 160 per elevator. So I think elevators would really be kind of a niche solution for areas where, maybe someone's willing to pay extra to have access to like a very, very convenient drop-off location. Or maybe it's like just meant for like, they'll offer it for free to people that have like disabilities. Because like, let's say if you're dropping off like right in front of all the stores on Fifth Avenue in New York City, you're not going to want to build up like 3 or 4 parking spaces worth of space, plus the loading and unloading area to have that right in such valuable real estate. That might make more sense to have elevators and higher cost for that exit point. But with ramps themselves, I'm pretty sure this is the right arithmetic to do. And I don't see why that would be the limiting constraint. However, if there is any good feedback, I'll certainly change this.
Yeah, I just want to add really quickly that my vision for the 16 passenger minibus is Elon talked about increasing the aerial density by getting rid of the driver in the aisle in the middle. So I think he's going to have doors. I think you're going to have multiple doors on both sides. So like every row of passengers is going to have a door. So maybe there might be 4 doors from front to back on each side to let the passengers out eat more easily. And that gets, because one of the goals is to get people in and out quickly, right? The system works better. People get in and out quickly. So everybody's got to be close to a door. You don't have to somebody to fold the seat over to climb out. It's got to be easy for them to get in and out.
But okay, so here's the thing though, many people have projected, Tony Seba in particular, who I think has probably the best chance of having accurate predictions, that if we see a large scale autonomous vehicle future, what in the hell are we going to do with all these parking lots and parking garages? There's going to be plenty of room. Like if you look at the amount of space that just this is the one station, what that one station with 14 stalls can do on either end of the Las Vegas Convention Center. And if that with a 12 passenger vehicle and this much load time, if that station alone could hit 40K per hour, I mean, seriously, go look at the map. Like it is a tiny speck on that vast sea of parking spaces. So like clearly we can make room for these giant cars. Like I don't think that's a realistic concern at all. It just doesn't take up that much space. And if you need more throughput, well, here, watch magic. Like it's not that hard. There's like thousands of parking spaces and it's just one more.
I don't know if people saw that. What Saxon just did was he changed the number of stalls from 15 from 14 to 30. The point is that a parking lot takes up a lot of space and the ramp takes up a lot less space. So if you just put a couple more ramps in, you can radically, if the ramps, the embarkation, disembarkation, whatever, if the getting in and out of the vehicles is the bottleneck, then you just make more space for them to do that. And that doesn't take up a lot of space. It's a very easy thing to do. Am I correct?
That's exactly right. Yeah. I mean, it's just a matter of geometry, right? Like the station is just not that large. We've already blocked off so much space for cars, which is one of the reasons I'm not a big fan of our current transport network, particularly here in the US and Canada. It's one of the most ridiculous transport systems ever devised. We'll get into that later, both from personal costs and externalities. So in any case, I don't think the ramps are the issue. My one question is really like, again, is there going to be issues with traffic in terms of like, do they all cause a bottleneck when they just gridlock themselves in the surface? But I think the reason they could probably get around that is right now, I'm pretty sure a lot of surface gridlock is caused by stoplights and by bottlenecks at the entry and exit of parking lots and parking garages, which have a limited number of entry and exit points necessarily because there's just not room for them. But we have heard from, I think Elon, I can't remember, but we've definitely heard that the boring company could build entrances to tunnels straight into parking garages. And we already have seen that they can do it straight into parking lots. So if you could imagine, like, let's say your typical parking lot is represented by the LVCC one, you could take that LVCC parking lot, and if for some reason the loop for Vegas is just getting so crowded that you need a ton more entrance points just in that particular parking lot for whatever reason, or let's say at any of the downtown casino ones, well, okay, just build more entrances in the garages themselves, and then you don't get interference on the surface roads between the cars popping out of one tunnel and in another, because they're not even interacting with each other. They're all just going straight to where they wanted to go. And then you get out and start walking or rolling or whatever it is you do. So I don't think that's really realistic either. And you won't really need the traffic lights for the most part. It can probably even just turn to stop signs because, you know, one, you're not going to have accidents on simple slow city roads if it truly is in the end state a 100% autonomous future. And as well, because people will have to traverse in the car such less distance across the urban environment, I'm pretty sure that also is going to help out because you're not going to need so many lights, because you could even just turn the urban roads above ground into like 15 mile per hour or less roads and make them mostly just for pedestrians and cyclists and scooters and wheelchairs. And instead of having them be like 25 or 30 miles per hour, as they usually are right now, at least again here in the US, that's where my experience is. So between that, I think you could turn it into all stop signs above ground. And again, going straight into the parking lot you needed to go into, or at least a garage right next to where you're going, that should solve the problem, I think, of gridlock at the surface. So again, if someone has a better actual informed analysis why that's not true, I would like to hear it so I can change this. But I don't think Thunderfoot's criticism is really something anyone should be listening to, unless they just want to laugh.
Well, he can be funny.
He is pretty funny. I think that's why he sucks people in.
Yeah.
His sarcasm is pretty clever, but the math I don't think is there.
Yeah. And he's not stupid. He's a chemistry researcher. He's actually a fairly smart guy in his field. Mm-hmm. This is not chemistry research.
Although, again, I'm not a traffic engineer. I work in statistical quality engineering. So do I know? I'm not sure, but I'm pretty sure he didn't look up what the actual traffic engineers have to say on this subject. I actually did to some extent. And this is what I found. Plus, like, this is not rocket science. Like, we know, like, this is just high school math, right? Like, this is how many stalls there are. If they're in continuous rotation like clockwork, this is how high it could get. You know, you might lower this a little bit, but again, if you don't like that, like, they selected it to have enough capacity. They could have just built more stalls, because autonomy, especially at 5 miles per hour, could absolutely have a headway of 1 second entering the tunnel. So again, not really a realistic criticism. Should we move on from throughput now, or are there
Sure.
any additional questions?
No, you're good. Let's go.
Let's go. All right. Travel time. That's the big thing here. But it's not really complicated enough that we need to talk about it. I think that's why we're all here. You know, if you could do a 15-mile trip at 150 miles per hour, plus maybe 1 minute of on and off ramp time, that's a 7-minute trip. That roughly lines up with about what the LVCC loop numbers have been proposing. So even with, you know, you have, well, plus maybe like a minute for acceleration and deceleration, that's probably, I don't know. This would be for trips that are longer than about 2 miles, I think, which is what's roughly 3.5 kilometers, I think. So travel time's awesome. That's why people are going to love this. So as far as station count per city, to go to the previous topic, I didn't put too much thought into this, but per Elon in the December 2018 presentation, he's expecting 10 to 20 times, so about an order of magnitude more stations than a subway, which makes sense because you're going to want a higher density. The stations are much, much cheaper than subway stations. I'm not sure by how much yet, which is why I didn't really account for that in the valuation part. If I got the right data, New York City has 473 subway stations within the city limits. I'm not sure if that's counting like the Jersey City and Newark side of the river, but just for rough numbers. So if we multiply that by 10 to 20, you'd be looking at roughly on the order of 10,000 stations in a city the size of New York. But it could easily end up being more than that. Depending on how low they can get the costs and how much people really want the convenience versus just walking a little more. And people may be willing to walk more if we switch to this future, because walking on the surface is going to be much, much more pleasant without all of the downsides of doing that around heavy polluting motor vehicles and crosswalks slowing you down and stuff. So we already talked about, like, are there going to be bottlenecks? So we'll move on from that. I didn't do the math yet, but someone else could if they wanted to. What would, if you had like 10,000 stations, let's say 5,000 just on Manhattan Island, you know, what is the distance between stations on average if you had them like roughly uniformly spread out? I didn't do the math on that. I don't think that's important at this time, because that would be far into the future of this system. Like, for example, we already know that the Las Vegas loop, they're planning for like 42 stations or something like that. It's low 40s. I don't remember exactly. So that kind of bounds like what we'd be looking at for something like this. I don't know what the exact ratio of ramps to elevators would be, but like I said before, given the way the throughput numbers work out, plus probably the cost as well, I would expect that the ratio of ramps to elevators is probably at least 10 to 1, if not more. And that's only in urban environments. I don't see any reason to build an elevator unless you just want, like, you have like a mansion and you want your own elevator to the tunnels. I don't think anyone in the suburbs or beyond is going to do anything but ramps, just because you don't have the land costs and space constraints. The other interesting question that I don't know yet is what would be the ratio of street stations to parking garage stations, like we're talking about. They help with convenience and congestion. Those are usually the bottlenecks. You could probably solve this if you double to 10x the entry and exit points, like we were saying.
Let me ask you a question here. Mm-hmm. Why would we still have garages?
Well, it would be something like that. The structures are already there, so we would probably adapt the existing structures, do something else useful with most of the space, and convert at least like the ground floors or whatever is the most convenient floor into a boring station, essentially. And then maybe you put like, I don't know, like an indoor urban garden or something like that, or you know, you convert it into some kind of useful space.
I think there's a sort of, what's your vision of the future? And for me, the vision of the future is that we're going to have very few privately owned cars anymore, and almost everyone's going to ride in robo-taxis. And if everyone's riding in robo-taxis, then there's no parking anymore, because the robo-taxi is moving on to its next ride. And I think you probably would tear down the parking structure and put something else, either leave open space or build something else in its space. Maybe you leave some of them up for the heck of it, but it seems like an awfully terrible use of the space. Does that make sense?
Yeah, I think so. That could be. The main thing is I don't know what the demolition costs are of dealing with tearing down the structure. And in many cases, especially in dense urban areas, I suspect that it might be more cost effective in the medium term of a few decades or whatever to just let the parking structure live out its useful planned for structural life, and then tear it down when it was expected to be teared down. But if it is cheaper, then yeah, I think you're probably right. I'm also going off the fact that like in Seattle, there are some areas where the government, especially post-COVID, where they decided they're going to make things like permanent, just walking and pedestrian and bike streets. And they've shut down certain like parking lots downtown. And with those, they didn't bother to rip out the asphalt. What they did was they just put in like a bunch of concrete flower pots and like some picnic tables and chairs and stuff like that. So that's sort of what I was going off of, but like, that's of course reasoning by analogy. So I don't know for sure whether that's really representative of what we're likely to see. In the long run though, yeah, I would expect to see not any parking structures at all. That wouldn't really make any sense. Once
Right.
you don't need to, well, or they'll be there, but they won't be in the urban core. They'll be out, somewhere in the suburbs, most likely, whatever is like the optimal distance for that city to maximize the trade-off between convenient access to the city versus land cost. And like, how does that affect your battery usage? Because you're going to do some probably non-value added trips, time of day stuff. Like, do you want to do it like during the day when traffic's a little lower and the sun's cheaper?
I suppose you could reconfigure some of them as supercharging stations and put a bunch of chargers, and when the vehicles come up, they go charge and then they go back in. That could be the second floor, could be superchargers.
I believe so. And please excuse me, I need to text about this time zone issue again.
No problem.
I'm currently blowing off my brother, but this is very exciting for me.
Okay. I hope your brother will forgive you.
I think he will. I came to visit him for 4 weeks. I'm in Houston. That's why I'm confused. My
phone's Houston.
My phone. I'm actually right next to Rice, by the way. If you have any good recommendations.
I haven't been there in a long time. If the House of Pies is still open, that's a great place to go. And Tex-Mex, there's lots of good House of Pies, and if the House of Pies is still open in Houston, that's a great place to go. There was a burrito place called La Jalisciense, which is probably gone.
Maybe, I don't know.
Tex-Mex generally is good in Houston, and Chinese food is good in Southwest Houston.
Yeah, I got some Chinese food. Well, so my brother's a grad student at the MD Anderson Cancer Center here. So there's a lot of friends he has who are Chinese because there's a ton of Chinese grad students. So we got I wouldn't have known what to pick. I don't know enough about that culture.
Okay.
So anyway, as far as station count, I don't think that's there's a lot more interesting stuff I think we can talk about. I want to talk about induced demand also, because I've seen this argument. I'm very familiar with it because I'm kind of a infrastructure geek myself. And I was actually fairly anti-car for the last couple years, but I think this changes everything in terms of what we thought we previously knew. So I'll just read this aloud. So because I already put together the words. So currently all over the world, there are roads which are not packed at full capacity at a given time. Even roads that are jammed during rush hour are usually deserted at 2 a.m. Therefore, roads do not always fill up just because the opportunity to use them exists at a given moment. Elon said in the 2018 presentation that they could build enough tunnels just in Los Angeles to transport the entire USA population simultaneously. Roughly speaking, we have about 350 million people by the time they build these tunnels. That's, let's say if you have 35,000 throughput per hour, that would be about 10,000 tunnels, which could plausibly be built in the LA area. They wouldn't actually do this, obviously. The whole point was the whole population of the US is not going to move to Los Angeles. And there's room for far more than 10,000 tunnels. Also, I'm sure you know this, Warren, but for those who haven't studied economics, induced demand is not really the correct term if we're using the economics strict usage of that term. Demand actually refers to a curve. It's a relationship between the cost of something that people want and the quantity that the market will demand. A lot of people get that mixed up semantically, where they talk about demand as just the quantity and they ignore the effect of price. So really, when people are talking about induced demand, usually what they're talking about is, oh, well, when you invest in like a new lane of road, typically what happens is it only briefly fixes traffic for like a day until people figure out that there's this new lane. Then they all want to take it, and then it fills up, and then you still have traffic. So what was the point? I think that argument is incorrect for a couple of reasons. One, back to the demand thing. Really, first of all, this is an increase in the quantity of transport demanded in response to a decline in the cost of transport, which the cost in this case that has declined is the opportunity cost and boredom cost and stuff of sitting, waiting in traffic. As well as the fact that the value of the good is effectively lower because you're getting there less fast. As we discussed, I think with a sufficient number of lanes and surface entrance and exit points strategically located, eventually roadway capacity is no longer the limiting factor on how much transport we demand. But there are other costs that are going to affect that demand curve still, such that the amount demanded is not going to skyrocket to infinity, where you just keep building more and more tunnels and somehow they keep filling up. The amount of transport demanded will occur to the point where the marginal utility of one more trip of transport equals the marginal cost for that particular decision maker. And in this case, if the limiting factor is no longer wait time, the marginal cost will be determined by one, the cost of operating the vehicle, plus two, the road toll. And so since vehicle cost is and always will be non-zero, and since there's diminishing marginal utility of transport as the number of miles traveled increases for all actors involved, we can conclude that demand will be finite rather than keeping up with any arbitrary amount of roadway capacity. And since we know, as Elon said many times, there's more room for tunnels than for buildings, there is no reason to expect that a 3D road network would be backed up, even in the densest of cities. Because also the density per capita of a building, because it has stuff in it and people want to walk around and everything, is necessarily going to be less than the density of the number of people in a given tunnel at a given time. So I think we can put the induced demand argument to rest. I believe the reason why critics are so convinced of this is that there has never been the possibility to build this many roads in a city due to space constraints and environmental constraints and safety concerns, et cetera. So I think people are reasoning by analogy here, incorrectly assuming that this will be exactly like previous road expansions without having actually done the math.
Okay.
Again, it's not really induced demand also, like even when we built previous expensive roadway expansion projects, those were, there was still value people were getting out of that increase in capacity. Like the fact that they were doing it and they weren't previously suggests that they wanted to do it. And now they're getting something that they wanted. It's just that we still, because they're not toll roads, we have this tragedy of the commons situation that you always get where you have a public good and no cost to consume it. And so everyone overconsumes it and gets in each other's way. Or then there's like me on the bike laughing at you guys in traffic, but
let me ask this. I think I have a sense of what you're saying, and an example I often like to use is, suppose we had a tunnel, a boring company tunnel from South Florida, where I live, to Disney World. Okay, yeah. And so what's currently a 3-hour trip, where since I can't drive home at night because it's too far, I end up having to pay for a hotel. So it takes me 3 hours. It costs me, $50 in gas and wear and tear on my car to get there, making up the numbers. Then I got to spend a couple $100 on a hotel. Now, suppose it's a boring company tunnel and I hop in one of these 16 passenger vans. Yep. And I get there and it's round trip for $20. And I can come home. Probably less, but let's just call it $20 round trip. And I can come home at night and sleep in my own bed and don't have to pay for a hotel. I think you're going to see because I know a lot of people in South Florida like going to Disney World. If you all of a sudden made it that you could day trip to Disney World and come home, I think you're going to see a huge volume of demand for something that no one knew existed before. Like I think everybody down here who goes to Disney World or has friends who go to Disney World, they're aware of this demand, but we don't perceive it as demand because it's not conceivable that it would happen. But you lower that cost to $10 round trip or $20 round trip, and now all of a sudden, I think it's $10 round trip, to be honest. If you have 16 passenger van. So, you and your wife or your girlfriend go to Disney for the day, and you get, Florida people get season passes. So your cost is so cheap that you're going to see this huge volume of traffic that, I don't know if you'd call that induced demand. It's demand that existed all along. We just didn't, there's no manifestation of the demand because the supply wasn't there at all.
Yeah, here, let me show, for those who haven't seen it, this is like day one of economics class that they teach you. Let's see, we need like Investopedia here. It's basically, it's a curve. So what Warren is saying is essentially that we've never seen this part of the curve where the cost is that low.
Right.
Oh, there's no picture, come on. Oh, here it is, different article. So this is a demand curve. So typically demand of something goes down by some amount that is non-zero as prices decline. And usually there's an upward sloping supply curve. So this is how a typical free market's going to work. So P represents the price, or in this case, just the overall cost of doing it. And Q would be the quantity, which is again, what people usually are saying, even in like financial publications, when they say demand is too high or too low, they're usually talking about just quantity, irrespective of price. Ignore D2, let's just look at D1. This basically shows you that as price is high, the quantity is low. And then with some rough shape like this, as quantity gets higher, as the price falls. So basically what we're saying is the price right now of transport has been pretty high. So we've been all just looking at like, I don't know if you can really see my cursor. We're basically in the top left portion of this curve. And with Boring Company lowering the traffic edge of things, maybe then the price just becomes like, I don't know, let's say this P2 line just for a reference point. Then now we're down here and suddenly the quantity is much higher than it was up near like where this arrow is coming from. So again, ignore the supply line, whatever. But the point is that the price has fallen so much of using it. It's not, the price doesn't go to zero and shoot us off towards infinity, because again, you still have to pay for the vehicle itself. You're gonna have to pay the Boring Company for a toll fee that's non-zero. So it's not just gonna be infinite.
Plus, let's look at this
that much.
Let's look at this for a second. Let's think about this as the supply of trips to Disney World from South Florida and the demand for trips to Disney World from South Florida. And currently the supply curve is all the way to the left.
Yeah, so imagine it's here.
The price is really, really high. And now all of a sudden you shift the supply curve way to the right because you've just created this opportunity where it used to cost, the price used to be $300 round trip. And now the price is $10 round trip. And it's like our normal concepts of supply and demand don't allow for that radical a change.
Yeah, it's like so far outside of what anyone's seen before. This is a massive step change. Yeah. But again, it just also doesn't go to infinity because one, this demand curve does not actually asymptotically go to infinity because no one, like at a certain point, what are you even going to do? Even in the most like implausible scenarios, what are you even going to do with that much motion? Right.
But I'm saying there's probably, you would probably get 100,000 people. Like right now, there's probably 1,000 people a day going from South Florida to Disney World, and it would go to 100,000 people a day. Like it's hard to grip how much more demand there is if you make it that cheap.
Yeah, exactly. So that's part of why we'll get back to this later, or I don't know, maybe let's see where we get to it. But I might be lowballing the number of miles people want to go in this system once it's at scale, because we don't have any idea what the actual demand curve looks like. That we just know that theoretically in the abstract, something like this does exist for the transport market, but it has never been able to be tested before, just how much demand there is. However, one of the good things about this system is unlike a large scale infrastructure project where you have to plan the whole thing in advance, like a high-speed rail train, this one can expand incrementally to basically just gradually push the envelope to test what the demand curve is actually shaped like in a particular market or whatever. Like there's gonna be technically a unique demand curve depending on, you start throwing in new factors like, you know, local culture, how many people are in that particular city, how much people want to stay home versus go out, et cetera. Whether it's like a manufacturing city or whatever, where there's a lot of goods flowing versus, you know, a more service oriented sector, or maybe many of us are working from home from now on, et cetera. I say, let's put that to bed. I'd like to talk actually about, one last thing, energy efficiency. people have said, oh, well, a car is so inefficient because you're moving around, at least 2,000 pounds of material for a 150-pound person, or here in America, maybe 200. So that is a lot of material per person, but that's assuming it's still just one person per car. Also, just for reference, a Model 3 right now, when driven appropriately, uses about 250 watt hours per mile. Walking for an adult is about 100 watt hours per mile if you calculate the number of calories they're burning. So even just with 4 passengers, a loaded Model 3 currently has better efficiency than walking. You move to, so even at 150 miles per hour where drag is really bad, if you shape it really aerodynamically, probably with some kind of nose cone instead of a frunk, you right size it for one person and their cargo. So it's more just like a Jetson style pod. And you roll it on some very smooth asphalt, or Will has proposed polished concrete. I don't know anything about that, but the point is it would have pretty low rolling resistance compared to surface roads that wear down more quickly. And it's operating in a good temperature, and it's using a Tesla electric powertrain, really any electric, but as we know, Teslas are the most efficient. This number probably could stay somewhere in the ballpark of roughly walking energy consumption, despite the fact that you're in a car and despite the fact that you're going 150 miles per hour. Also, the suspension system, because the roads will be in such good condition, I think you could make it much stiffer. The road's not getting bouncy because like heavy trucks are like compacting the soil underneath it. And so you'll end up, you probably have seen this, you guys, there's like waves, especially at heavily trafficked intersections. You have like waves in the surface where trucks have over the years just compressed the asphalt and compressed the soil underneath it. You won't have any of that because all the heavy stuff is going to be in other tunnels. And the stress on the road grows with the cube of axle weight. So you can do the math on that. Roughly an order of magnitude more damage is done by semis than just regular cars. And you don't have ice, you don't have thermal expansion and contraction, you don't have UV radiation, you don't have tree roots, and you don't have shifting soil, all of which makes for roads that are longer lasting and better quality because they're just sitting on top of concrete, which is sitting on top of bedrock. So back to that, you can make the suspension system stiffer, that's a mouthful, without really sacrificing comfort at all. And that would help energy efficiency somewhat because having a bouncier suspension lowers your overall drivetrain efficiency. I'm pretty sure that's mainly through rolling resistance. I don't totally remember. And then the other big one is that unlike a train or a bus, even an electrically driven bus, there's no energy waste from frequent starting and stopping because it's point to point, not only is that more convenient for the customers, but it's basically continuous flow. So even with a state of the art, probably the best you could do with an electric powertrain, being very generous, maybe you could get to 95% round trip stopping efficiency from like 30 miles per hour, which is what a train does. That's a 5% penalty, realistically more like 10% penalty every single time you start and stop and get back up to the same speed. That adds up really quick if you're doing 100 stops just in one day's route. Much more efficient to be able to just only stop once. Last thing on this, if we have no questions.
Oh wait, so I just want to cover that point because I might have missed that. So what you're saying is because your individual pods, whether it's a 4-passenger Model 3 or a 16, they're going to be making fewer stops because you're going to get in the vehicle that's going to the right place. It's if you have a 100-passenger train or a 1,000-passenger train, it has to stop at every stop. But your boring vehicles don't have to stop at every stop, and so that saves energy. Exactly.
So let's say hold all at constant. Let's say you used, I don't know, like some Tesla powertrain, like the Model 3 Model Y powertrain, to drive the train. So you designed a train that was powered by that, so that we're holding that constant. How much energy does even an efficient Model 3 4680 battery pack lose? It's going to be non-zero. That's thermodynamically guaranteed to happen. Anyone who's driven this can see that. The amount of kilowatts you burn on the way up is less than the kilowatts that it says you're getting when you do the regen braking, and you always lose a little battery. So that actually makes it surprisingly efficient. Plus, I think that I talk about this somewhere else. I don't know why it's not in here. You also, because everyone's in an enclosed tunnel, there's this thing called the piston effect. So you've got the cars are basically like a fist punching through the air of the tunnel. That's why they have aerodynamic drag, but they're leaving wake in their behind, just like you see like a speedboat, right? And so if you have like a chain of speedboats all in that wake, they actually don't face that much resistance. Neither would these cars. So even if you don't do like the now you know channel is proposed for freight trucking and have a fan blowing at like 90 miles per hour, you know, I don't know exactly what it would be, but that helps you because you're basically flying with a tailwind, at least in the high capacity scenarios, because the cars in front of you and the cars behind you, you're all working together to push the same mass of air. So when you put in platooning, I think the energy efficiency is actually great. The only thing that might beat it is a Hyperloop, but that's not going to be for right now. We're just looking at lower speed city transit. We can get to that later if we have time. All right, if you'd like it, I think the really interesting part here is going to be the construction and also debunking some of the safety myths. Would you like to move to that next?
Yeah, sure.
Let's start with safety because that's simpler. And it's also the thing I've seen the most uninformed criticism of. So we will not mention Thunderfoot again.
It cracks me up.
Yeah, oh, hang on, I gotta get rid of this search box.
Well, so, but what about all the pedestrians in the tunnels?
There will be zero. Okay, so there are NFPA, I think that's the North American standard for fire safety.
They're going to slow down for school zones, right?
For our underground schools, yes. So there are NFPA 130 safety regulations, which are what apply to this particular tunnel project. It was verified in detail per the contract, which you all can find if you read the link at the bottom of this page. I think it is. It's somewhere in here. Third-party local consultants who had a strong financial interest in being able to find a flaw in this system and then have the feather in their cap saying, hey, look, we stopped this project before it killed people. They said it was good, and so did the Clark County, Nevada Fire Department, as we would expect for any construction projects in any developed nation, such as we do have laws. The world is not that corrupt. So that evidence alone is very strong that this is safe, but we'll go forward anyway. Also, most people are not so evil that they would be complicit in knowingly allowing a dangerous construction project to go forward. And even if they were so evil, among all of these parties, the equally evil and money-hungry lawyers would be waiting in the wing to sue for violations. Please correct me if that's wrong, Warren, but I'm pretty sure that's how it works. That would be a litigation nightmare.
Yes.
So slip-ups and malfeasance do happen rarely in terms of like Americans with Disability Act violations or whatever, but definitely never so obvious that losers such as lazy journalists and the internet peanut gallery can spot the flaws on site. It's always some obscure thing. So, I talked about the consulting. Also, yeah, the engineers who specifically signed off on this system, put their name on it, could face loss of their PE licenses and potentially prison time. I would even say probably prison time, but I'm not a lawyer. And the kind of people, I know this is a quality engineer, the people who are willing to self-select into the profession of being inspectors generally intrinsically care about quality and safety more than the average person. And usually there will be at least one person who will make a fuss or refuse to sign off on something that's wrong. And you can see the inspection documents on the Clark County Citizen Access website. Everything's been signed off of. And yeah, Elon is an asshole sometimes in interpersonal relations, partially because he has mild autism and partially because he doesn't suffer fools easily. I think all the available evidence points to him having a strong sense of justice and caring for humanity's well-being overall. Tesla and SpaceX's safety records are stellar, and this very person is attempting to make money by ferrying humans into space. So he has a very strong vested interest in, even if you think he's evil, in not having people believe this system is dangerous. Plus, more importantly, existing motorways are quite dangerous. Motor vehicle accidents are the top cause of accidental death and injury in developed nations. these systems do not need to be perfect. They just need to be substantially better than the alternative to make a big difference in overall transport safety.
Let me just address that really quick, because I am a car accident lawyer and a criminal defense lawyer dealing with a lot of traffic. Most of my criminal work has dealt with vehicles. I mentioned pedestrians before. The easiest way to die in a car accident is be a pedestrian, because if you're in a car, you're surrounded by all this steel or aluminum or metal. You're in something that's designed to survive a crash. When you get hit by a 4,000-pound vehicle going 30 miles an hour, it tends to kill you, right? So that is the most dangerous type of accident, is when a vehicle hits a pedestrian, and the tunnel system is going to have essentially zero pedestrians. There's going to be the stations, and it'll be designed so that the people aren't walking where the vehicles are moving with any speed. You're not going to have kids crossing crosswalks. You're not going to have, like you think about the Uber accident where the safety driver wasn't paying attention and the woman crossed the street in a bicycle at night wearing dark clothing, with the reflectors taken off the bicycle. That's not going to happen. The things that cause pedestrians to get in accidents with cars are simply not going to be here. So could there be a fender bender in the tunnel? I suppose it's possible. I think that's still also very unlikely to happen. You're just going to see a lot fewer accidents. Yeah,
versus globally 1.3 million deaths per year. And again, getting back to the demand curve, it's roughly like in the US, I think we're about on the order of 1 death per 100 million miles driven. You can influence that with your own personal safety habits, but it's still pretty bad. It's a lot worse than airplanes. It's actually worse than the 737 MAX thus far, for comparison, which we get a lot of flack for. I'm not on that project, by the way, but I'm just saying, cars are quite dangerous, and this will fix it. So anyway, so that's basically, if you don't want to skip these technical details you're watching in the future, that's
actually,
fine.
Somebody asked about emergency, so if you could address the emergency issues.
All right, so emergency egress, I would recommend watching Will's videos on this, but this is just a summary.
And when he says Will's videos, there's a channel called The Boring Revolution. Last I checked, Will was in the chat. I'm not sure he's still here. Will is a Brit. He's in somewhere in England, as far as I know.
I think he said Manchester. Yeah, he's much further behind or ahead of us. So even if the tunnel is totally filled with cars, if there's a crash or fire, all of the cars can rapidly exit, even in reverse, because the station density is going to be pretty high. And again, it's built to regulations. And because cars can move faster than people can get out of a defunct car and start walking or rolling down the tunnel, the emergency egress aisle, which is 112 inches wide, the whole width of the roadway, the walkway will be clear of vehicles. The only one that's going to be stationary is the car that's defunct. And there will be, as regulated per proven safety regulations, walkways and exits that meet the standards necessary to ensure safety. Again, if you think they're not matching this, I don't know what to tell you. We have rules that have to be followed, and if you don't comply with them, your system does not get to work. And someone is going to make a fuss if you try to do that. And if not, the lawyers will sue and win. So, and I also hear Will's gone into depth on this. I'm not going to do that again here. So the width of the tunnel is 112 inches just on the ground. The actual tunnel diameter is 120 inches because it's circular and it's 12 feet across interior. A Model 3 and Y is 6 foot 10 inches wide. So at a minimum, if it were perfectly centered in the lane, you're still getting 15 inches of clearance on either side of the car. And 30 inches if most likely all the cars pull over to the side. That's enough. Plus you can kind of walk up. I don't know exactly what that would look like, but I'm sure they've tested this. You don't get this far without doing that. So the NFPA 130 allows a maximum of 2,500 feet between emergency exits. For the LVCC loop, the tunnel segments are just barely short enough to meet that. So they don't have to build any extra emergency escape shafts in the actual tunnels. Will had predicted in a comment I sent to him on his channel, 650 meters. That, at least for American regulations, comes out to 770, but he was about right. For the extension to the Encore Resort Tunnel nearby to the convention center, the minutes in the January board meeting of the Convention Center and Visitors Authority says they approved a perpetual easement to, quote, permit provider to construct and maintain an emergency exit shaft, end quote, for the Encore Resort tunnel. So clearly they're intending to do that because that tunnel is longer. I think this might be wrong. I was speculating. It looked like in a slow-mo of the video that there were maybe doors every 100 meters or so where there's like a change in the tunnel wall pattern. I don't know exactly where the blue light emergency phones are going to be, but they are going to have them. There are emergency egress placards on the wall. Again, you can see that in the fire protection report. I'm not going to go in detail here. Anyone who really wants to see this can just read the report.
Just a quick note. You had said that 12 feet diameter. I think that means that the tunnel is actually 144 inches wide at the.
Oh yeah, sorry. Wrong
and
math.
then the other quick thing is Cybertruck is going to be able to. I think the 16 passenger vehicle will be more like 80 inches wide.
Yeah, something like that.
So I think
again, like they've thought of this. Like
yeah.
You don't get this far. Like if someone was just proposing this, that's one thing. But this has already been signed off. The fire marshal signed off on it. They're pretty picky. Like they're not just going to let something fly. So anyway, like the safety standards in construction are much higher than the safety standards that we are willing to allow on our existing roadway system. It's totally irrational. Anyway. For earthquakes, I don't want to get into this too much. You can read this quote on your own time from just the first link I found to a civil engineering book about this. Simply put, tunnels and airplanes are the safest place to be in an earthquake. Everywhere else on the surface is where the actual waves are happening. This is not a problem. Anyone who says this didn't even bother to spend 10 seconds typing tunnels and earthquake into their favorite search engine. So
I always people, I get this comment a lot, and I always say, well, give me an example where a tunnel was compromised by an earthquake.
Yeah,
we've had tunnels for like 100 years, right? Maybe longer.
Over 100. Yeah. I mean, the London Underground, I think the Thames Link or whatever, that started getting built in, I think, 1820 when they were mucking out the dirt. So it's been a long time.
So where's the example of the tunnel that collapsed because of an earthquake? Where is it? That should be on. You should be able to find that on Google.
Yeah.
What about the volcanoes, Saxon? The volcanoes. If a meteor strikes the earth.
Well, you'll be safe from that too, man. It's the thing. The surface of Earth is dangerous. Underground, the bedrock's nothing. Okay, for disability accessibility, again, first of all, this is ridiculous on the face of it. In America, we have the Americans with Disabilities Act since the 90s. You do not get to build a project that doesn't comply with this. The lawyers would sue. There are literally lawyers who specialize in suing over this, lots of them. Again, if the violations are that obvious that armchair critics can spot them, the lawyers would already be preparing the lawsuits. That doesn't happen. Also, the one thing that's more interesting, though, that isn't as obvious is in the case of an evacuation for a fire, for example, the system is set up per the FPR to for people who can't climb the 17.5% grade ramp, there is an aerodynamically separated safe zone. So we'll get into fire safety, but the basic fire strategy is just to blow air fast enough that the smoke all goes in one direction. But on top of that, if somehow you were stuck in the direction where there is smoke, there's some kind of just like waterfall of air it's blasting that like keeps you safe in a small waiting zone until someone can come help you get up the ramp. So there's isolation for people who can't self-rescue. So that's taken care of. So fire is the interesting one. That's what I keep hearing. Oh, well, what are you going to do when there's a fire? Will's touched on this. I have not seen Will mention the fire protection report yet. I'm not sure if he was aware of it or not. I hope he can give a more informed video on this, but here's what I'm seeing for now. First of all, if we're going to do rational risk mitigation, you have to multiply the probability of a fire proven by data times the probability of a catastrophe in the event that a fire has occurred. That determines your overall probability of catastrophe. It's Bayes' law, basic prob stats. First of all, as noted in the report and many times by Elon, fires will very rarely occur because for a fire, you need to have both an ignition source and highly flammable materials that can catch on fire. This doesn't really have any ignition sources. Unlike a subway, there's no high voltage third rail. And unlike existing roadway tunnels, there's no flammable oil-based fluids entering the tunnel. except maybe in a specialized tunnel, or maybe it gets cleared out for that one truck or something. I don't know. There'll be far fewer of them when we don't have gas or diesel being used. Additionally, for the foreseeable future, this is going to be run with Tesla 4680 batteries. Tesla's legacy battery technology already had a demonstrably low fire risk. That's been debunked. If you've watched Warren's channel, I'm sure you've seen that. But then also, they're switching to the lithium iron phosphate chemistry, which has an inherently low risk of thermal runaway. I won't justify that here, but that's been known for a long, long time. And in urban areas, which is where the tunnels are actually going to be full enough that this matters, it'll probably be all LFP or almost entirely. Plus, if you saw on battery day, between the continuous perforated tab, I don't like calling it tabless, it's really more a continuous tab with perforations, plus the Maxwell DBE, you've basically solved the thermal problem, because anytime you do have like a short that's shunting the battery and starts generating heat, the capacity of this thing to suck that heat away and not let that cell overheat and then start a cascade effect of failure that leads to fire is basically zero, because you're cutting the thermal path length from the entire length of the jelly roll, which I think is like for a 4680 cell is like about a meter. You're cutting that down to just the height of the can. Both cases, it's on average half. I don't know if you guys can see my hand.
We can see your hands, yes.
Yeah, that's what I'm trying to show is my hands. Anyway, so you're basically cutting the thermal path length from to about 35 millimeters from maybe 400 plus millimeters. So not only does that help you wick heat away faster, but you're also reducing the heat that's generated in the first place, because the electrical conductivity path has also been cut by exactly that same amount. And then on top of that, the DBE from Maxwell reduces the internal resistance of the battery because the hangover from the solvent used in manufacturing, causing issues with the solid electrolyte interface, and their binder is relatively conductive. So that's demonstrated here. You probably recognize this slide from Battery Day.
Yeah.
This is where they mentioned the challenge with big cells is charging. So this is with conventional legacy technology, how bad the heating issue gets and consequently charge time. So the new cell's right here at 46 millimeters, but as you can see, the new cell curve, it's basically flat. There's essentially zero thermal issues at all. So the likelihood of a fire even happening is, it's probably something that's going to be so rare that you hear about it on the news once in a while, sort of like plane crashes.
It's interesting that you mentioned LFP. I mean, Elon has said that the robo-taxis will be primarily LFPs. For those who don't know what we're talking about, lithium iron phosphate is,
as opposed to high nickel or manganese,
is an iron-based battery, has lower energy density, which means that you don't have as much range for the same weight of battery or the same volume of battery, but at the same time, it costs a lot less, and it actually has some advantages, like it's less prone to fire, and it also allows you to charge to full capacity. So it has a longer battery, longer cycle life, longer battery life. So there's a lot of advantages to it, and those advantages make a lot of sense in robo-taxi use, which will be a lot of the vehicles in the tunnels.
As an aside, I think that's one reason why historically Tesla went with the high nickel cobalt for a long time in the early days of EVs, when everyone else was using crappy LFP at the time that had really, really low range of like less than 100 miles, in some cases less than 100 kilometers. Because they were the only ones that understood enough about how the batteries worked and how to control them, and that understood enough about how to design a really high class battery management and thermal system, which enabled them to get to the point where they are now, where they can do a properly commercially viable pivot back to LFP that everyone else started with. So anyway, the risk part of the probability of fire occurring is very, very low. The walls are also concrete that are fire rated. So what is actually dangerous about a fire is 5 things. There's the heat, there's the toxic gases released, there's the lack of oxygen if you're in an enclosed environment, there's issues with visibility, and there's also potentially, back in the days when systems didn't account for this, there were some cases of like people being trampled during the panic of exiting the building. So this system has to knock out all 5, and the regulations demonstrate that they will. The first 4 hazards are all wiped out by the ventilation system, blowing all the dangerous hot smoke downstream and providing clear, fresh air for people escaping upstream. So that's basically how it's going to work until the fire department arrives. There's also going to be, I think, 250 gallon per minute flow pipes, standpipes that are in the grates in the floor. So the fire department can then come in afterwards and just dump a bunch of water until it's cooled off enough that, and plus with that, plus the wind blowing fresh, cool air past the vehicle, that's also going to cool it down. Emergency escape is also just fine. That just requires clear air, adequate lighting, an accessible pathway, and clear, simple egress instructions that are very intuitive while people are panicking. This system has all of that. So even if we account for panic and people at the lower end of the intelligence distribution, people will have a very strong natural instinct to walk in the direction that the fresh air is coming from. And from the website, so it also says they have emergency exits, fire detection systems, fire suppression systems, a fire-rated first responder emergency communication system, tested frequently with local police and fire departments. Additionally, this is going, I think, above and beyond what the regulations require. The network has a fire command center for each loop system that will have 100% camera coverage, which is not typical of subway systems. And it will also have a team of professionals, probably aided by computer vision within the tunnel, to monitor the system to prepare for rapid emergency response. They will likely hit stuff before the carbon monoxide, smoke, and heat detectors can find the fire. So there's multiple ways of triggering the emergency ventilation system. All they have to do is hit what's called critical velocity, and then all the gas is going to flow in one direction and everyone's getting clean air. We can go more into this if you want, but I'd rather move on. This just goes into like pictures of the geometry, how the ventilation system works. I took some snips of key parts of the report, but it's 82 pages. You can read these details for yourself, I think. Should we move on from that, Warren?
Yeah, please.
I think autonomy is more interesting.
Well, are you gonna address the risk that it's going to crash into a wall or crash into another car? Is that part of this?
Yeah, essentially, the autonomy part is the part I'm least certain about because that's not as proven as basic fire safety, where again, you just basically have to blow the air in one direction and have water available and make sure people can get out. So as for autonomy, that's the biggest wild card. However, we do already know, assuming Tesla's data is not just flat out fraudulent, autopilot already greatly outperforms humans on freeways above ground, and yet we can expect a drastic improvement in performance in a controlled underground environment. Some of the things you were mentioning before, like meteorites and lava, are actual literal problems on some above ground roadways that they have to deal with that do not exist under tunnels. No pedestrians. It will be 100% autonomous cars, so there's no human morons doing stuff. And also importantly, I don't know if you want to get into this. Autonomy of computer vision is fundamentally about detecting signal out of visual noise in a given video stream in order to get information on the drivable space, which is necessary for path planning. And at a basic level, because the tunnel is so standardized everywhere in the world where it's going, it all looks exactly the same. And the only difference is how far ahead is the car in front of you and the turns, which it can very quickly figure out. So the noise floor in the visual information stream is extremely low in comparison to even the simplest highway above ground. You don't have varying lighting conditions, you have no weather, you have no surprises, there's no animals, there's no trees, there's no shadows. Even just the slightest shadow of an anvil that Wile E. Coyote has thrown in the road, 200 meters ahead, it's going to detect that faster than you even could. So I think just from those basic first principles and the proven performance we already have above ground, I really don't expect that there's going to be any accidents in this tunnel. I think this is honestly almost trivial in terms of autonomy, given what we know they can already do. Furthermore, because it's a tunnel network, HD maps actually kind of makes sense if they need it, because when you construct this project, you're going to have probably centimeter level accuracy on knowing exactly where the roadway is. So there's no ambiguity about what the drivable space is. The system knows that in advance. And it could drive reliably blind without even having any cameras or ultrasonic sensors. Also, the likelihood of hitting a wall, I think, is very low, not only because it can have that HD map, so it knows exactly where the gore point is, for example, at a split point, but also, you know, it's got these ultrasonic sensors. It can feel if it's getting close to the left or right wall just by the sonar of those sensors saying, hey, you just moved 2 inches to the left. You need to go back right and get yourself centered again. Plus, we've got very, very clearly marked lane lines that, again, below ground roads are going to face a lot less environmental stresses. So those lane lines are probably going to be pretty much pristine for decades. No one's going to be driving over them, etc. I'm guessing you have a similar opinion, Warren?
Yeah, no, I think it's comical that people, because I had just had this conversation in Clubhouse with people who should know better, and they're like, well, you can't go 150 miles an hour in a tunnel. Like, well, you can go 150 miles an hour on a highway lane. Yeah. Why is this different from driving on a highway? You know, and everybody I've talked to who knows autopilot really well says it's exceptionally good at lane keeping.
Exactly.
Right?
Exactly.
It's actually one of the ways you would distinguish a self-driving car from a human-driven car is you would notice how perfectly it stays in the lane, and you would figure that can't be human.
Yep. I mean, basically, if we'll get into the first principles for a second. So you've got measurements. The video stream is basically a bunch of pixels with a vector at each position in the array, representing measurements from the camera for red, blue, green, brightness, and saturation. So basically, you're going to have statistics that have a very low variation for each pixel, except that it's going to translate over space as the car turns. But that's very easy to account for with a neural net, or even just basic manual linear algebra. So anytime there's a foreign object in the roadway, you're going to have an extremely statistically anomalous set of measurements from some patch of pixels in the net. So I could be 10 beers deep and doing this by hand in a spreadsheet, and you couldn't even tell me what the pixels are representing. You just give me the numbers, and I'll be able to type with one hand and figure out where the anomaly is, because the measurements are going to be so obviously different from all the measurements that preceded it. I think it's very unlikely that it's just going to not detect something. And if it does, again, that's going to be so rare in comparison to human-driven accidents above ground. You know, that's the standard we've got to beat. So at this point, I think arguments against that are basically just grasping at straws at this point, or they don't realize how good it is at lane keeping, or they didn't account for ultrasonics on the walls and HD maps, which actually work well in tunnels, because tunnels cannot possibly just change quickly. They would know.
Well, you saw the. Did you see the video where the Waymo had trouble because they put up construction cones?
Yeah, I think so.
I don't think they're going to be marking off lanes on the tunnel.
Yeah. You know, and yeah, there's not going to be like a festival in the middle of the tunnel, like where you have to divert around it or anything.
Yeah.
And yes, they are using drivers right now. That doesn't mean this is a scam. Like they're just making sure it works. They're going above and beyond to just convince people. I'm sure internally they know it's going to work. It also may be based around, like, you know, making passengers more comfortable with it, because they're already nervous about fire safety and stuff because of all the FUD, some of which comes from their own minds and not knowing any better. But the board meeting minutes, again, from January, you can see this yourself with this link. It specifically says that it recognizes the intent for the system to move from drivers in the vehicles to autonomous operations, and provides for a fee negotiation for that no later than December 31st of this year. And that was 4 months ago. So clearly that is what they expect to do. They just have not described that to the public yet, which I think is why people are confused. Given that I know your audience generally thinks Tesla autonomy will work pretty well, I think we can probably move on from that. You've discussed that at length, and basically this just comes down to, this is a much easier version of what you already think is likely to succeed. So the main question, like I was saying before on throughput, is how good can this get? How low can you take the headway in number of seconds? Because that's going to determine your max throughput. Although you may not need to push it as far as the 0.1 seconds I was talking about, because you're not going to need 500,000 from one lane. There's no one who wants to do that. At that point, just build more lanes. Or maybe that's like a short tree trunk, like going down Fifth Avenue in New York, you know, but then it quickly branches off.
Yeah.
So individual vehicles aren't on that lane very long. So we already talked about defunct vehicles blocking lanes because that's basically the fire scenario. Again, there's going to be emergency exits. As long as the vehicles can react quickly enough, that's not going to be an issue. People can get out. The big thing here is it's not just one tunnel. It's a network of several of them with constant exits every 2,500 feet minimum, which is about half a mile, roughly a kilometer. So I don't really see that as a realistic issue. And even so, like if a car does break down suddenly, it's not like it's just going to instantaneously stop. If it's moving 150 miles per hour, it has a lot of momentum. So like if you have a tire blowout, you're still going to be skidding downstream along with the cars behind you. So the actual collision velocity is not the velocity of the car relative to the tunnel floor. It's the collision velocity of the car and the car in front of it that just had a blowout or whatever.
I would say also
that's not actually that bad.
Blowouts are probably more common with high performance tires, and they're probably a lot less common with the types of tires you would put on a robo-taxi.
I agree with that. I saw that criticism from some people. I know Boring Revolution already discussed this as well. I just wanted to discuss that here. You're not going to ever have T-bones or head-on collisions, which, as I'm sure you know, Warren, are really the worst ones.
Yes.
And that's fundamentally impossible in this tunnel. So I really don't think you're going to see a whole lot of deadly accidents compared to what we're currently experiencing. Just due to vehicle blockage, faster than the braking system can actually respond. Probably just a minor bump. I won't get into this because you can watch Will's video on this, but I don't think floods in the water table are a serious issue. The big one here, if you just want proof of concept, there are tunnels in Miami. There's a tunnel under the Chesapeake Bay. There's a tunnel under the English Channel. There's a tunnel in the Netherlands. Half their country is below sea level. Clearly, this is not an issue. You just have to hermetically seal the tunnel so that water doesn't come in. I don't really think that's a serious issue. You just put grout and sealant in between the concrete segments and problem solved, as far as I know.
If you go back on my channel, you search my channel's videos for Florida, you will see I interviewed a Florida geologist, David Wilshaw, and he debunked the whole thing. He actually consulted, I think, on the Port of Miami tunnel, but he debunked the whole issue very well. And Will did a video where he talked about it too.
That's exactly, those two videos are precisely what I'm going off of. So I fully agree. And again, this is not hypothetical. These tunnels already exist. So clearly it's possible. Roadway debris, I'll skip that for now. Anyone who wants to see this, there's no way that someone could sabotage this without getting arrested before they even leave the tunnel, because there's cameras everywhere. The windows are probably going to lock if there even are windows in the long term. So if you tried to throw an anvil out the window, it's going to be extremely obvious that was you. You're going to get arrested and you're going to go to jail, probably with a felony for attempted murder or something. I don't really think that's a realistic outcome, but if you want to see more on that, you can read this section here.
Now you got my idea for windowless cars.
Yeah, exactly. I'm serious. Either that or they use maybe the Cybertruck like Elon glass or something. I don't know. There's so much evidence that would be against them. The car, they don't even get to operate it. It's going to stop them and just wait for the police to arrive. I don't think there's any, and also people could sabotage the roads right now, and yet they don't do it. What's stopping people from throwing, banana peels on the road like it's Mario Kart? They don't do that.
There's actually much less likelihood for it because there's no pedestrians who are walking around to be able to litter the highway.
Yeah, exactly. So I think criminals, that's not going to be a serious issue. For turning radius, this was another ridiculous Thunderfoot criticism. Obviously, the cars are going to slow down to accommodate whatever turn they designed it for. It is hard to believe anyone genuinely thinks this is a problem. That's just silly. People go fast on straightaways and then they slow down on turns, and the autonomous cars will do exactly the same thing. And if you don't want to have a turning radius associated with 155, all right, go 30, go 60, whatever it is to make it work. That's trivial. Elevators and ramps, this I'm not sure of, but there's probably a standard solution because this isn't the first time someone's ever made a hole in the ground where people are walking around. Probably some kind of fencing along with like warning alarms or something.
You talking about elevators for humans, or are you talking about elevators
No,
for the
no,
cars?
elevators. So like I've seen some arguments that like it's going to be super dangerous in a city to have like holes in the ground that people might walk into, or like let's say you have a person that can't see and they fall in it somehow, stuff like that.
Yeah, but
I don't.
we have elevators to the subway in New York City in places.
Yeah, I know exactly.
There's a door in a building, and the elevator is not like you step on a hole on the spot on the ground and it drops down. There's a wall for a building, and they put the elevator in the building, and it goes down from the building, not in the middle of the sidewalk.
Well, but I'm going off of, you look at the Hawthorne tunnel, I'm not speaking of that type of elevator for like emergency exits. Well, they probably won't use elevators, but it'll be a stairwell that's like that.
Yeah.
The current solution is actually just a hole in the ground. And so their like concept videos have also shown just holes in the ground. So you need to come up with something. But again, for this to get approved, they'll figure something out.
Yeah.
I don't think that's a serious concern. Now, here's one that our current transport system does not actually do very well, but a boring loop would do an excellent job of, is pandemic safety. In my opinion, ideally, all critical infrastructure for our civilization should be prepared to accommodate all predictable natural disasters. Obvious environmental hazards include extreme wind, hail, lightning, earthquakes, floods, heavy snow and ice load, and wildfires. Right now, existing mass transit solutions, though, do not deal with pandemic hazards. This one wasn't too bad, but there's worse ones coming. There have been worse ones in the past, just in the 21st century. And all epidemiologists are projecting increases in both the severity and frequency of pandemics as the 21st century progresses. I'm inclined to trust their projections based on what I know. So I think we need a transport system that can keep things moving very smoothly, even when this is occurring.
Can I just add to this?
Uh-huh.
So one of my big ideas, which is future, is pod car robo taxis that are single passenger.
Yeah, you could have those too.
And
pay extra.
And if you did that, if they were, let's say, 3 feet wide, which they might be even smaller than that, you could have, and people think this is crazy, but you could have two running next to each other in the tunnel.
Yeah, probably.
You would actually double, and then because they'd be much shorter front to back, you might actually, it's not going to be as efficient as having a 16 passenger minibus in a sense, but you're still going to have fairly good throughput if you have these things running. With
more than fairly good. Let's go back to the calculations again. So in your scenario, let's adjust. So this is the autonomy, mostly individual scenario. So let's say the tunnel is 1.1 passengers per vehicle. Even with relatively conservative headway estimates, you're still getting, a standard highway lane right now is 2,000 when it's not blocked by an accident or snow. This would be every day of the year, pandemic or otherwise, you're getting about 13,000 per hour in that scenario, which is more than enough for most routes. That's better than some trains.
But this is without doubling the width.
And that's even without doubling. Yeah, exactly. So effectively you would turn it into 2.2, and then you're getting better than, that's like roughly an average train as far as I know. So yeah, that could work perfectly.
And this accomplishes your concern about pandemics, is everybody rides at their own vehicle.
Yeah, I mean, let's say Ebola actually breaks out finally, and there's actually serious concerns outside of just certain areas of Africa with something like that, or like, Asia, which has higher population density, they have had serious concerns with like SARS, for example, before this. And something's coming eventually. We've had the bubonic plague. We've had a lot of serious problems in our history. We just have a tendency to forget about them as soon as they're over. But it's certainly something we should plan for, just like we planned for 100-year floods, for example. We don't want to have to shut everything down when something even more serious than COVID arises, where it's a serious safety issue. So yeah, as far as safety, I think this is the best way to do that. Oh, note, airplanes are an exception to this, by the way, just as a Boeing engineer note. They have HEPA filters, just like a Model X. They're blowing you clean air from your overhead vent. There's no real risk.
They studied flights coming from Wuhan.
Mm-hmm.
If you look in the Google Scholar, you can find at least one article about they studied like passengers coming. There were identified passengers who were symptomatic who flew from Wuhan to Hong Kong or other destinations, I forget where. And there was several flights, and no one on the planes got sick, not even the people sitting near them. So
they're cycling the air every 30 seconds on a plane.
And it's people massively overestimate the probability of getting sick from a symptomatic person or asymptomatic person near them. It's the most common side of transition is in the home, where you're spending, days and days with the same person in close proximity. So
yeah, if you think COVID was probably maybe a reproduction constant of 3 or 4, for example, which is pretty high compared to something like influenza, which is already pretty contagious. And that was with 0 precautions. On something like a plane, just again as an aside, that doesn't have the same issues, because you're getting fresh air from your vent from partially the upper atmosphere, which is ultra clean, and partially recycled air that goes through HEPA filters, which filters out all particles, including ones that are as big as a virus. So anyway, I think that's another major advantage here, is that this is also pandemic safe, which currently buses and trains are not as safe. Especially if you're taking them daily. So, that's why they were emptied. So overall, I think I agree with a Boring Revolution's assessment. This is going to be by far the safest mode of transport that has ever been devised on every level. I don't know if there's something I'm missing, but these are clearly the big ones. It's earthquake safe, fire safe, crash safe, pandemic safe.
Yeah, you nailed it.
All right, now let's get to the cool part, construction. So there's a lot of there's some stuff I really want to actually hear anyone's opinion who knows more than me about TBMs, because some of this I'm just speculating. But there's been criticisms that, oh, he invented the tunnel. Great. We already had those since 1820. Well, they apparently neglected to read the website. They're tripling the power in large part just by shifting from diesel. A lot of people seem to have missed this. What Elon does when he wants to start a brand new idea is he first goes and figures out who the top supposed experts are in the field. And because he's Elon Musk, he says, hey, can I call you? Or his secretary says that. And they're like, yeah, of course, I'll talk to Elon Musk. And he asked around, and the first question he asked, which is, as he said, obvious from a physics standpoint, is, are your machines thermally limited or power limited? So thermally limited would mean that it's so hot, you're doing everything you can to get rid of the heat, and you're just up against the limits of how much the materials can handle before they start deforming. Whereas power would just mean, let's add more motors and electricity, basically. And he found that none of these chief engineers even knew the answer to the question. And he dug deeper and he found out that they actually are power limited, not thermally limited, which is good because you can crank up the power. So they're going to triple it, which is one of the big reasons why they will be able to drill faster, is just cranking it harder. Again, this is all I think you should see a Boring Revolution. This stuff, he discusses all of it. They're going to do continuous mining. So they're going to be basically, once they've got it going, it's not going to be basically batch production. It's going to be continuous flow, where the segments are going up simultaneously with continuous 24/7 drilling. So you're gonna get mining percentages from maybe like 10% of the time, from what I'm hearing, to hopefully 100%. So that right there is a factor of 10 improvement. Again, you got surface lunch and porpoising. Go check out the website or Will's videos if you want to see more about that. They're getting rid of the rail trucks. So they're improving the logistics of getting muck out of the tunnel between using the rubber wheeled vehicles pulled by an electric tractor, along with feeding that straight into brick or concrete production. So that's a lot more efficient than hauling it off for disposal and then paying for the disposal. We don't know exactly what this will look like, but just given baseline what we know about how Elon Musk operates, they're probably going to do intensive vertical integration, which will probably bring costs down. They're going to start making their own precast concrete lining, probably in situ. They're probably going to produce their own construction vehicles. I'm pretty sure this is all verbatim from the website. We know about the tunnel size reduction. I just mentioned repurposing dirt. So you're turning a waste into a resource, which is a big flip around. That saves you probably at least $1 million per mile by my math. And then just the all electric approach, you don't have to deal with diesel fumes. Additionally, this isn't on the website, but I suspect, based on the trend from past Musk companies, that there's probably going to be better operating software on the TBMs than there currently is. Not sure if that's exactly a constraint right now, but it seems likely that if it is, that they will improve upon that. Any comments so far?
Yeah, so My general sense, you're talking about the key innovations. Number one, I think the biggest innovation was going to smaller diameter tunnels. That if you have the diameter of the tunnel, you quarter the amount of work that you need to do. And then your point about power, I think there's more. I mean, you've kind of covered all these points. And ultimately what this means is if you're able to tunnel more miles per day or more feet per day or whatever you want to say, more time. If you're able to, if you were able to tunnel 2 hours a day and now you're able to tunnel 6 hours a day, obviously you're going 3 times as fast, but also you're reducing costs because the labor cost is the same whether you're tunneling 2 hours a day or 6 hours a day. So there's a lot of costs that go into the tunneling that if you can go, and I think ideally you go from 2 hours of tunneling a day to 10 hours of tunneling a day or 15 hours of tunneling a day. And those things are major. They increase the speed of tunneling. They reduce the cost of tunneling. I think one of the other questions that I don't know the answer to is how much electricity does this use? Like how many kilowatt hours are you using per mile of tunneling? And
I'm not sure. Let's get into that. Let's get into that because I think that's the cool part. Well, first of all, just a second.
Well, if we're going to get there later, go through your list.
This is just mostly rough estimates based on a boring revolution. TBC claims they're already at under 10 million per mile, and they haven't even started using most of this stuff yet. Mostly they just cranked up the power and shrank the diameter thus far. This is a total guess, but if you want to play with these numbers to the valuation on your own, anyone who's reading this, you can do that. So like if you change this number, it's linked to the other sheet. That's just a rough guess right now. Now, the big thing that I haven't heard anyone talk about yet, and I have no idea whether this is even realistic. The website says that Prufrock's medium-term goal, not long-term, medium-term goal, is to exceed 7 miles per day, which is absolutely bonkers because let's do some back of the envelope math here. If every tunnel boring machine is getting 7 miles per day, that's about 49 per week, 2450 miles per year per TBM. That's 5 inches per minute, which is 12 seconds per inch. This is going to generate immense amounts of heat. But let's say if you were trying to drill 1 million miles of tunnel in 5 years, and let's say, I'm total guess, each TBM is maybe 10,000 miles. This may need to be changed a lot. I'm not sure about that one. But just as a rough guess, maybe you swap the cutter heads or something. That's 82 TBMs to dig a network faster than competitors could even figure out the R&D of how to replicate this. So you could have a worldwide network with economies of scale, all the best routes, all the best station locations, and network effects that are extremely powerful due to probably pretty high switchover costs, unless they cooperate with the boring company and do like a joint venture, kind of like how airlines will effectively join up to form larger airlines to get greater route density. I don't see any fundamental reason why, if they can achieve this actual speed and come up with at least like 100, maybe 1,000 TBMs in 5 years, you can just have them all drilling in parallel. You could deal with an entire city at once in like a few months. It's ridiculous.
I would say it differently. I didn't worry so much about the life of the TBM. My thought was, let's just say a mile a day. Let's say they don't come close to the 7 miles a day and they get to a mile a day, which would still be spectacular, right? If you did a mile a day and you want to do 100 miles of tunnel, well, number one, it's only 100 days to do 100 miles of tunnel. That's not bad.
3 months.
Right. But if you were in a hurry, well, then you throw 4 TBMs at it and you get it done in that much faster. But so like, my fantasy is the boring bearing thing, which eliminates all Pacific cargo.
That's on the Hyperloop tab. We can get to that if you want.
Right. But I'm just saying that, 24,000, I mean, you're talking about 1 million miles to bore, right?
Well, yeah, this is on the valuation. There's already 65 million roads worldwide miles. So this is actually a tiny fraction.
Okay, sorry, go ahead. So you have a number $5. Well,
I agree with what you're saying there is basically the reason why capacity would matter is if the constraint is, like, let's say if you're trying to get this done in 5 years, is the limiting factor speed of boring, or is it the rate at which you can construct TBMs to replace the ones that are falling apart?
Right. That's why you need the machine that builds the tunnel boring machine.
Yeah, that's why I wanted to look at both, because it could go either way as far as I can tell right now. But these numbers seem pretty reasonable given how quickly they constructed Prufrock already. And this was the prototype version. Once they settle it out, I mean, look how fast they're building starships. I don't think this is much more complicated than that. You know, it's not ultra mass production, but I'm just, trying to get a sense of like, do you need 1,000 TBMs for this or 10,000?
You're saying it's
Probably
not
100 to 1,000.
You're saying it's not rocket science.
Yeah.
No, I would say this. My guess would be that the tunnel boring machine, there's different components, and the cutter heads probably need to. There's a thing at the front of the tunnel boring machine that's interacting with the rock, and those probably need to get replaced more frequently. The electric motors that drive the tunnel boring machine are probably very, very durable.
So he's talking about this part. So maybe probably this part's very durable, but the head itself, who knows?
Yeah, you're replacing the cutter. You're replacing the cutter heads more frequently, so that costs something.
It's like having a drill, and you have to replace the drill bit every couple hours if you're reusing it. Same thing.
Exactly.
Except they're a lot harder than drill bits. We'll get into that when I'm talking about material selection later. So the other reason to estimate that is just to get a rough sense of what is the capex it would require over a 5-year period to construct as many boring machines as it would take to build this quickly. So with these numbers, it comes out to, about $500 million, which is very, very reasonable. Very, very, very reasonable.
That's stunning.
That's like as much as 1 mile of train. That's why, like when I emailed Warren about this, I was saying I was getting astonishing numbers. This is one of them.
Yeah.
It's 7 miles per day. So how could they actually do that?
Yeah.
Go ahead. Comment? Right,
no, I was just going to say that, when you're talking about $5 million a mile for the tunnels, if that's the expectation, then that's including the capex on the TBM. I think it's some of it's capex, some of it is electricity, a lot of it is electricity. I think they're using a lot of electricity to bore tunnels, and there's labor.
Yep. So here where we're getting the electricity and thermal thing. So what would it look like for a tunnel boring machine to max out the physical limits of thermodynamics in terms of how quickly can you grind apart the crystal structure of rock? So I think what they probably did when coming up with this number is I bet they calculated, there's a concept called specific energy of a crystal. That's referring to, like, for a given amount of crystal, what is the total energy of bonds between the atoms that's holding them together, and like how much work in the physics sense of joules would it take to break that down to a given particle size. I don't know what this is for the typical rocks, like what is it for granite, what is it for, chalk, whatever. But they probably did something like that. That would determine at a minimum how much electricity it would require after you account for powertrain inefficiency and stuff. And the logistics part's probably a lot less energy, but that'll require some. So then from that, you could calculate the heat that a given rate of boring would generate from all those atomic bonds breaking apart to get to that level of particle size. They probably calculated, and we'll get to this in a minute, of what I think they might do, the limit of heat removal with a very, very good liquid cooling system. And then the limits of the best possible cutter head material selection before heat and pressure from the drilling causes rapid deformation of the material. So that would be the first principles of how can you get to maximum boring speed is these 4 factors right here.
Can I ask you something?
Absolutely.
We're generating a lot of heat as we're boring the tunnel, and we need to cool the equipment so that it can keep going. And Tesla's really good at heat pumps. So is it possible that Elon's companies are very good at
They wouldn't use a heat. I don't think they would use a heat pump because of what I think I'm going to propose that they would use. And also because the reason heat pumps work is they're basically, thermodynamics, the second law, I think it is, says you cannot do any work for free. Everything that ever happens increases the total heat of the universe. And when you're in a confined environment in the tunnels, and there's very low thermal conductivity of the concrete into the bedrock.
Sure.
So with like a Model Y heat pump in the winter, the reason that's better is it's borrowing heat from the atmosphere and putting it into the car.
Well, that's not where I was going with this. Where I was going with this was, would the boring company be able to find a way to use the heat that is generated to generate energy or do something useful with that heat?
Oh, actually, I didn't think of that. I'll have to look at that. I can't think of any obvious reasons why that would be true, but that's very intriguing.
Well, if you're going to do liquid cooling, you're going to be heating the fluid.
Yeah, that's a good point. If anyone has informed comments about that, I would love to review them after this.
Yeah, I don't know if Will's still there. I don't know, Will, if you thought of that, let us know what you think in the chat.
I doubt it. It's kind of throwing off my, like, this sounds thermodynamically impossible for that to be positive gain, but I'm not sure. I'd have to double check that. Here's what I think they'll do. I think the main thing is actually not the electricity side that matters. It's really just about the rate at which you can cool it off. So for items number 3 and 4 about limits of heat removal with good liquid cooling, as well as cutter head selection material. So the ideal material would be extremely strong at high temperatures and pressure, especially in compression. It would be very thermally conductive, and it would have to be, if you were taking it as far as possible, it would have to be microscopically porous, like a foam, which I'll get into in just a sec. What that would do for you is it would let coolant, like in this picture here, probably this open cell version on the lower left, it would let it flow through pores in the material, where you get a very, very high internal surface area to volume ratio, which is your fundamental constraint. So if you're looking at how do you cool down an object, you're going to use conduction with fluid convection. That's the way you can remove heat from something. If you want to maximize that, you need maximum surface area to volume of the material you're cooling. You need a good thermal conductivity of the coolant. You need a high specific heat capacity of the coolant. You need a high specific thermal conductivity of the material you're cooling. You need a very high flow speed of the coolant fluid. And you want the coolest possible incoming fluid that you can, so that you can store as much heat in it before you have to pull it back out. I think they're probably just going to use regular antifreeze. I looked this up. It's the gold standard. It's 50-50 ethylene glycol and water, same as you'd put in a car or any other major machinery. I think it's very unlikely that it's possible that there's a better way, but they surprise us sometimes. So maybe they'll invent something new. But let's just go with antifreeze. So we could look this up. I didn't do the math yet, except I did look up the specific heat capacity is about 3,000 joules per kilogram degree C. As for flow speed of the coolant fluid, I think that's just a matter of cranking up the power, maybe with the heat pump, I don't know. But it's probably just some massive hydraulics that would force coolant fluid through whatever system to do it at the maximum flow velocity you can. And as for minimum temperature incoming, the freezing point of standard antifreeze is about -50 Fahrenheit or about -40 Celsius, 45 Celsius. There might be a higher freezing point under high pressure, though. I'm not really sure how it behaves. I'd have to look that up. Let's get into the metal foam, though. Here's where I think they're going to have to use this. First of all, the cube square law. Are you familiar with that, Warren?
No, I'm not.
Okay, so if you think of like a sphere, for example, the volume of a sphere grows with the cube of the radius.
Yep.
But the surface area grows in proportion to the square of the radius. So if you do the math on that, for every order of magnitude increase in the feature size of that sphere, the radius, the surface area to volume ratio decreases by an order of magnitude. So it's the ratio is inversely proportional to feature size. Like if you think like in biology, the reason why our cells are the size that they are and not much larger is because they're limited by the membrane around the cell and how much can go on in that membrane. So that's why they ended up so tiny. So if you were to go, let's say, from a monolithic chunk of metal in that cutter head backing, let's say it maybe has to be 10 centimeters thick to deal with the immense pressure they're talking about that would be required to drill through an inch of rock every 12 seconds. If you can switch that to a foam like you're seeing on the screenshot of the top left of the quadrant, which I'll go back to in a second, those little segments there are about 100 microns thick, so it's 1/10 of a millimeter. This is actually a mistake. That's supposed to be 10 to the third. You're getting a 1,000 times improvement in the surface area to volume ratio that you can use for cooling of that cutter head. 1,000 times. So that's why I think they'd have to switch to something like this if they were really going all out. I think this is also a SpaceX advantage as well. In aerospace, where weight is at a very high premium, another advantage of metal foams is they have extremely high strength to weight ratio also, because that also tends to depend on the square cube law. That's why our bones are shaped like this. Instead of just being a giant massive bone, they're actually porous like this because it's a lot more lightweight. I think that they could probably use, SpaceX is almost certainly using something like this somewhere on their rockets, and they may be doing advanced material science in this relatively unexplored area. They might be able to be using that to help design the cutter head. But the basic concept is right here. If you can have your ethylene glycol fluid flowing through a microscopic structure where like this, it's maybe about, these little segments are about 100 microns across, the surface area to volume ratio could be so high that you can, I think you can absolutely wipe out the thermal problem. And at a certain point, it's just like, you know, maybe you're just grinding the material away faster than you're overheating it, which would be how they would have to do in order to get to an inch every 12 seconds or faster in the long run. Let's say an inch every 10 seconds. I got more notes on metal foam. I did see tungsten carbide, I think, with maybe diamond encrusted tips is probably the material they have to use. From what I was able to find, it looks like that's the most common cutter head material already, because it's the strongest, cheaply available material. Like for the Mohs hardness is 9 out of 10, like diamond is 10, this is 9. Like I think aluminum is like 6 for reference. So they already commonly use, from what I could see in this paper here, the drag bits, which are the parts that are actually doing the scraping, I think. I'm not totally sure about that, are typically tungsten carbide with 6% cobalt. They're already very hard. And I found an example of a lab success where someone was able to produce a foam of tungsten carbide. So that at least demonstrates that it's possible to do this. This is more speculative, but again, I think if they were really to max out what is physically possible, this is what you would have to do. Getting back to these things, this is how you cool something down faster. If you can increase this this surface area here per volume by 1,000 or even 10 or even 100, that would be massive for how quickly you could cool, because you can flow the coolant through the crystal structure of the metal without necessarily sacrificing the strength, because most of the metal in a mass of just a like beam of metal, a lot of that's actually going to waste. The real strength, I'm pretty sure, is in the tension of the crystal structure. So when it's like when you've got a beam bending, the tensile is around the top of that beam are where the actual strength is coming from. Because if you bend further than that, eventually the crystal starts pulling apart and then you start getting rapidly accelerating fatigue, which is not what we want. So in just a brick of metal, a lot of the mass is actually going to waste. Plus that mass is in the way of your coolant fluid. So you can only cool it maybe through channels inside of it. This basically just takes that concept and turns it into just a whole lot of tiny channels that the coolant can blast through. What are your thoughts on that? I have not heard anyone propose this yet, so I could be totally off here, but I'm pretty sure this is what they would have to do.
It makes a lot of sense to me.
Okay. Do we have any comments on this? I'm really hoping Will
it might be a little over my head. Let me see what the chat says. Jim Whitehead says diamond films have high heat transfer, would work great. They can be made by vapor deposition. Jay Lizard says the strength of the crystal structure depends largely on its symmetry. Jambe says tungsten carbide with Thor's hammer. I think so, makes some reference to Thor's hammer. Okay. Jay Lizard says, what about ceramic or diamond?
Well, so tungsten carbide, from what I was reading, it's like, they call it like a metal ceramic. So it's like partially metal, but it has properties a lot like a ceramic. So I think that's why they use it right now. I tried to look up like, what are the toughest materials and hardest materials out there? There's various ways of measuring this. It's kind of a fuzzy concept when you get into the details. But it looks like out of the available options, tungsten carbide seems like the best. It beats like titanium, for example. Also, as an outside shot, if someone wins a Nobel Prize coming up with like really good graphene, maybe that could work because it has very good thermal conductivity. It's very easy to get a regular structure with graphene, as far as I know, if you can manipulate it well, because it's basically just like chicken wire fencing made out of carbon. We've got like just an array of hexagons as far as the eye can see, microscopically. Maybe someday, but I don't think that's something anyone could make right now. But that's where, like, if Musk's team comes out with ridiculous materials engineering, maybe graphene could work better. Because graphene is like diamond, it's still a carbon network, but it's a lot better than diamond in terms of hardness and thermal conductivity, I think. Don't quote me on that though. I'm not a materials guy. I just looked this up earlier this week. So yeah, that's what I think they're going to have to do for cooling. And again, I think it would come down to your original electricity question. You could calculate how much energy would the cooling system require? How much energy would it require to break apart the rock in the first place? And how much heat does that, make the cooling system need to remove? Maybe can they recycle some of that into like curing the bricks or something? I'm not sure how that works. But this could be calculated, and I'm guessing that that is what they did when they came up with this 7 miles per day number. So it seems like it probably could be plausible if it truly becomes thermally limited by early editions of proof rock, because of that roughly 1000x improvement in surface area to volume ratio. So if, like someone said, maybe they need a symmetrical crystal, so they might move to the regular cell metal foam style. That one also has fluid flow benefits because you can get more like laminar flow because there's not turbulence caused by the chaotic, randomly oriented network. So that could actually improve the fluid flow speed part of this equation right here. So a regular crystal structure would have a very high surface area to volume, plus you could get a pretty good coolant fluid. Plus you're also slightly like turbulence generates a little heat. I'm not sure if that's significant or not at the fluid flow speeds we're talking about. Again, someone please comment, I'll review it later. I hope to flesh this out more. And if Warren, if you can put my email, if anyone wants to send me more of a detailed analysis of this and tell me where it's wrong, I would appreciate that for any of this, but especially this part. Because this part's at least less speculative. It's more just actual science.
You sure you want me to put your email up?
I don't know. I guess you have more experience with that than I do. I've never been on a podcast with this many people. It's not a bad plan. Okay. Okay. I mean, well, it can be a dummy email. I'll make a fake email account just for this purpose, and we can send to that. How about that?
Okay.
Or maybe because I feel like people can't respond in the chat fast enough.
My email is public and it doesn't bother me, but other people might be bothered.
Okay. So. Yeah. Well, why don't we do that then? How about you forward any major comments?
Okay.
I know sometimes people actually know what they're talking about and respond in detail. So
there's a lot of good comments in the chat.
I don't have time to follow them, but I will review. I do need to see my brother today. I'm only in town for another week, but
okay.
And I already accidentally flaked on him. So bricks, this is a minor consideration, but it is pretty cool. So the tunnel diameter is 14 feet across, not for the inner diameter, but the actual bore hole diameter. So you calculate the cross section, how much stone powder per mile do you get of cubic feet? That's about on the order of 1 million, it's about 800,000 per mile. So let's say if it's like, I did a calculation on like average brick size. So I'm assuming 4 inches by 8 inches by 2.5 inches. That appears to be about the size of the bricks they've been making because they're like roughly normal brick size based on people holding them in their hands. So that gives you roughly the potential material for about 17.5 million bricks per mile, which is a lot of bricks. That's where the point I get into this comment. If they dug 1 million miles of tunnel, is there really a market for 10 trillion bricks? Probably not. That would be vastly above the current 25 billion that I see as the current brick industry globally. I'm also totally guessing on cost per brick. Will did say they'll probably have about 1 cent of cement per brick. So that puts a floor and it's at least 1 cent. But they're saying they're going to sell them for 10 cents per brick. So that could potentially be, with these numbers, it can lop off about, or it can give you positive cash flow about $1.2 million per mile. Plus you're saving like 15% over normal tunneling costs.
Really quick to be aware of, I believe that some of the material they tunnel through will not be good for producing bricks and some of it will be.
Probably, yeah.
So, you figure half the time you'll get useful bricks and half the time you won't. So you're down to half as many bricks.
Yeah, but then at the same time, the question is, one, how much, again, back to the demand curve thing, this is yet another thing where it's a totally untested portion of a given market's demand curve. I've seen bricks this cheap, to my knowledge. So surely lower prices and potentially higher quality would increase the market for bricks. It remains to be seen how much. But also, maybe if not bricks, this is where I would need a civil engineer to actually comment on this. Could it be used for construction aggregate? Like I know sand is getting harder to find now that's high quality. It's getting harder to find gravel that's cheap and high quality. So could this like replace existing gravel pit mining and basically be a major feedstock, if not the primary feedstock, into certain concrete and foundation construction? At least from my level of knowledge, that seems plausible. And Will did say in this video, which I have linked here, that it could potentially be used for this application. I don't know enough though to know that for sure, but it doesn't seem unreasonable. And also, I'll get this later. I haven't seen anyone talk about this either, but it's also outside my expertise. It's possible that in certain areas, there will be valuable minerals in the dust they're generating. And they may be able to extract value from that. You know, maybe there's like several tons of copper, for example, in a mile of tunnel you were already going to drill for a transport purpose or something like that. And that can maybe help with the overall economic proposition.
Nickel. We need nickel for batteries.
We need a lot of things. More materials is always good. Here, general construction notes that I got from Will. There's like little voids in the tunnel segments. He said those are for bolting them together, which makes sense to me. I'll take his word for it. And we're still predicting that there will be hexagonal segments on future tunnels with proof rock to enable the continuous mining, with also building the structure at the same time. But that's still just conjecture at this point. We don't actually know. That has not been announced. So that's what I got for construction. I still don't know how reasonable this number is, but given the bounding of what they're currently claiming and the fact that they bid 50 million for the Vegas project, that's a pretty good sign. And that was their first try. You know, it wasn't with all the new stuff.
I definitely think you're going to see on the station side, I think you're going to see some much larger stations, because the stations could be a revenue. Certain stations could be a huge revenue opportunity for putting a restaurant adjacent to the station, or
concessions, you
Yeah.
know. It could be. I do think though, I'm just guessing here. I saw in the fire protection report multiple instances of the phrase where they mentioned that there will not be like a list of like concessions and other things like that in the stations at the LVCC loop. What that suggests to me, but I have not looked this up, it suggests to me that there are probably different fire safety regulations when you include concessions and stuff like that than when there isn't. I'm not sure how much that would drive cost up versus just having people go under the surface and find a shop.
Hey, Saxon.
Uh-huh.
One of my chat commenters said that I should invite you back to do this another time. Do you have to go?
I probably should. I would love to, because we haven't talked about Hyperloop. I want to get into mining.
So let's plan on doing a second session of this.
Yeah.
Is there anything you want to say before we wrap up today? Because we've been going for nearly 3 hours.
Well, let's just get to the dessert then. If these construction numbers are reasonable, and if we're anywhere close on estimating the miles, let's just take it down to 1 million, just to be safer. If this company, it seems like it's currently valued at about $1 billion, and yet I'm predicting, based on just some net present value discounted cash flow models, that this would be worth about $23 trillion for 1 million miles of tunnel. And that's not even accounting for all the positive externalities, which we can get into next time. I think that's a good reason why I personally want to invest, but you know, they probably won't make it back into their checking account. But it's still very, very good for society overall. So we can talk about that next time. I also want to talk too into some things on Elon Musk's leadership philosophy and why I think that's part of why people are totally misunderstanding what's going on here and are so dismissive. As well as, like I mentioned at the beginning, I'd like to see some more discussion on certain methods that maybe Tesla and in particular the Boring Company are using that align with lean manufacturing principles, and how they're basically making everyone else look like fools, even though everyone already knows about this that works in industry.
Yeah.
So I think I'll sum it up with this. There's a famous quote: "Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away." And Elon Musk had a widely derided statement. We simplified this a lot. It's basically just Teslas and tunnels at this point, which is way more profound than it sounds.
I love it. Okay.
Yeah,
so
thank you for having me.
So we'll do it again in a couple of weeks, or maybe you'll do it on Will's channel.
Potentially, I'd love to. And hopefully I'll have an actual desk this time. I will not be in this condo.
Okay. Listen, Saxon, thank you very much. Everyone, thank you for watching. Of course, check out the t-shirts. Thank you to the Vasa Law Firm in Sweden and all my Patreon supporters for helping this channel grow. Links to everything in the description below. I'm going to stop the stream, and Saxon, we'll just talk for one more minute.
Okay.